Hello? Hello? Happy Saturday. Okay, Ellie, I was really worried that I had just been playing my music too loud. And that's what deafened you. But if you just don't have audio, then that's not terrible. But yeah, I mean, has everyone enjoyed the start of their weekend? I guess Friday's technically the start of the weekend, but yesterday my Friday was so packed that I didn't really feel like it was weekend, right? Didn't have time to like unwind, you know? But how's the audio right now, Max? Hey, Perry. Happy Sunday for you then, Perry. I mean, I guess. Silly East Coaster. Silly future people. Y'all future people. Time travelers. Can you tell me which lottery numbers win? Can you give me the winning lottery numbers so that I can win and then I never have to work again? Man, I really would love just a huge influx of money so I could retire. And it's like, it'd be so great to win the lottery, but I also, you know, I don't want to pay to play the lottery. I mean, statistically just too bad, right? Statistically too bad. And us dumb, derpy STEM people are very perceptive to the numbers, I think. Sometimes not, right? Sometimes we girl mathin'. But the lottery, I mean, I know too well that shit literally just statistically so bad. If I don't give you my credit card details, the world is going to explode. Okay, so, hear me out. Hear me out. Let it explode. Let it explode. I'm okay with the world being destroyed. I'm okay with it. Send it all up in flames. Send it all up in flames. I mean, maybe it would be like good for the world, right? Good to get these despicable humans out. I mean, maybe not good for the rest of animals, but I'm sure they'll find a way. Find a way. Life finds a way. But yeah, I mean, yesterday we sort of were just yapping and talking and reading Reddits. And part of what I planned on doing was like watching some YouTube videos yesterday. But we didn't get around to that. So I sort of want to watch them today. Because what happened was, my favorite YouTube creator, like a couple months ago, Stuffmadehere, right? That's his YouTube channel. Makes a lot of like cool robots. And a couple months ago, I think it's oh my god, it's a year ago. Shit, time really flies. But anyway, he made a robot that solved puzzles. And it didn't work that well. But 2 weeks ago, Mark Rober released a video on Mark Rober's robot that solves puzzles. So I'm really interested to see how they compare. I'm really looking forward to it. Cause Stuffmadehere's, like I said, you know, had some issues, which I'll be honest, I feel like are sort of normal for him. Very indicative of like the normal nature of the engineering process. But yes, Rax, a couple months ago. It wasn't that long ago, and my perception of time is definitely not skewed by the fact that I'm ancient. I'm definitely super young, and yeah. We don't talk about my messed up perception of time here. Ooh, give me 1 sec, I need a drink. But yeah. I feel like Mark Rober has like, he's got like a full team that works on his projects. I think probably more than like, he probably manages, it seems like he must be running a lot of projects at the same time. This Old Tony released a new video yesterday too. Who's This Old Tony? I'll have to like make a note of that, and then we can look at this old Tony afterwards. Because I wonder, is that also like STEMmy engineering-y content? I'm always like pretty interested to see this stuff. See like number file videos, you know? Veritasium videos, smarter everyday videos. It's all cool stuff, right? All cool stuff. 1 second. Boop. Boop. Also, okay. For some reason, I felt like I wasn't seeing the Twitch chat on my stream preview, but it's working. Okay. Excellent, excellent. And what we want is do 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 do. Okay. Excellent, excellent. Like this, maybe? On machining. Okay. Very interesting mystery. Machining is like... I'm sure that is like very similar to stuff. Stuff. I am curious to see what he has content-wise then. We can take a look at it afterwards. Actually, do we want to look at the Stuffmadehere video first? The OG? Or do we want to look at Mark Rober's first? I feel like we should sort of watch Stuff's first. Because he won the race, so he sort of deserves to get seen first, I feel like. But this is his video. And I was pretty
Isn't it great?
impressed. Wait,
it's neat, but we're not even doing anything.
It gets better. Wait until you see it work its magic. It's the future. Why would I spend my time having fun when I can build a robot to have fun for me? Imagine a robot that can sort out all the pieces in a puzzle and...
Huh? Excuse me? YouTube?
Isn't it great?
I mean, it's neat, but we're not even doing anything.
It gets better. Wait until you see it work its magic. It's the future. Why would I spend my time having fun when I can build a robot to have fun for me? Imagine a robot that can sort out all the pieces in a puzzle and figure out their shape.
I actually don't know if I
really
think
hard to figure out how they fit together
and then assemble it in one straight shot.
It's a super interesting problem with all kinds of challenges. But if that isn't spicy enough, it's designed to solve what may be the world's hardest puzzle. A puzzle that's all white.
They say it takes over a month to solve. And that's because you have to search through every piece every single time to find a match.
Do you know what would be even harder? 5,000 pieces, all white. They don't even make that. This is just a normal 5,000 piece puzzle that I'm gonna paint all white. If you do the math, it should take about 2 years of 18-hour days to solve this puzzle.
Wait,
if you're doing it at a more leisurely pace, it's more like 10 years to life. And as terrible as that sounds, if this was a real product, I bet there's people that would buy it. My original plan was to use my robot arm to do this, but the puzzle's bigger than I thought, and there's no way to make the robot reach the entire puzzle without putting it on top of another robot to move it around. So that's just not
like for those little tiny
So what I'm gonna
pieces.
do is build a big table with a gantry built into it that will move a little cart around, which will pick up and move the pieces. This is gonna be a lot easier to explain when I actually have it, so let's get this thing made. Step 1 is to make a giant table because 5,000 piece puzzles are huge. This thing has like 150 parts, so I'm printing as many as I can possibly get away with. Everything else is cut from raw materials using a variety of sharp blades. I can never get over having the CNC making parts for me while I'm doing other stuff.
Guys, do you, like, any of you have experience? Wait, no, some of you do have machine shop experience. Like, how much, these machining, like the CNC mill must be, like, really expensive, right? I thought that stuff like that was, like, 20, 30 grand. Like, this...
I can never get over having
This is a super precise machine, and precision's, like, really expensive, I thought. So, I would think that these things are, like... It wouldn't even surprise me if it was, like, 6 figures, but I don't know.
the CNC making
I
parts for
don't.
me while I'm
It's
doing other
crazy how
stuff.
much money people have for just like sort of hobby stuff. I guess this is
All
his
right,
job.
now he's got to bolt everything together. The pieces all move without hitting each other, which is a great start. There is a lot going on with this robot, but fundamentally it's only doing
It's so
two things.
fast.
Moving pieces around and taking pictures of them. The robot's using a little suction cup to pick up pieces because it would be really hard to make a little hand. The suction cup is on a little platform that can move up and down, and it can also spin to get parts in the right orientation, which really complicates things. The vacuum system rides on bearings and is rotated by this servo motor. All of that is lifted up and down by this funny little RC car shock. We want to be able to push firmly but not destroy everything if there's anything that gets jammed up, so the shock provides some wiggle room. If you want the pieces to ever come off the suction cup, you need a way to turn it on and off. So it has a hole in the middle of it, which we can either attach to a vacuum to make pieces stick to it,
Okay.
or not, to make pieces fall off it.
I'm using a compressed air powered vacuum, which sounds like you should just shoot the piece off, but it doesn't, and the way it works is awesome.
This is another air-powered vacuum that I have, which is used for cleaning. Air goes in here and shoots out the back, and somehow it creates a bunch of suction on the front. The pressurized air goes to a special nozzle that makes
reminds
a
me of just
high-speed
the
cone of
normal
air.
vacuums.
The air inside of the cone is just chilling and minding its own business, but you can't really have air moving fast past air that's not moving. So the fast-moving air just pulls the still air along with it. This creates a continuous flow of air, which you can use as a vacuum.
That's such a like really good explanation for it. By the way, like such a clean graphic. I don't know how he does these, but he does a really good job. I wonder if he hires someone to do his editing and this sort of animation, or if he does it himself. But this is like such a clean diagram.
Pulls the still air along with it. This creates a continuous flow of air, which
Rex, why did you? I know that it's true that people spend thousands of dollars on furry suits, but I that one just caught me off guard, Rex. Just caught me off guard.
you can use as a vacuum.
This may seem like a roundabout way to generate a vacuum, but it's so much easier than the alternatives. All you need is a solenoid valve to turn the air on and off, which are cheap and really easy to control electrically, and then the little vacuum generator, which is a piece of metal. The automatic piece picker can be moved anywhere on the table with this gantry, and it's going to be moving a lot of pieces. So my main design goal was to make sure that it could move quickly. And as with many
It
of my
does move
projects,
really
if you want it to go fast, you need it to be light.
Achieving
some of his
speed is why this
oldest
gantry
things,
has
and
such a strange belt
everything
design.
he builds is so
To understand what's going on, let's start with a simpler arrangement. We could have a motor moving a belt like this to move the cart back and forth. And then we could have another motor moving another belt to move this beam back and forth. But this double stinks because you're moving a heavy motor, and if you only push on one side of the beam, it really wants to bend and break. What you really want is a belt on each side of the beam pulling it. But this still stinks because we're moving that heavy motor. And this is where things get cool. Imagine if I reroute this belt like this. Now the belt will move the cart left and right. And then if I reroute the other belt in the same way, I have this very strange looking arrangement. If I pull on both of the belts like this, they pull on the cart in opposite directions and it cancels out. So it stays still, but the gantry beam
This is
moves
so
down.
cool.
But if I
I
move one of
forget
the
how
motors
cool
less
all
than
this
the
stuff
other
is.
one, they only partially cancel out and the beam and the cart move together.
Yeah, Rex, it does remind me of the Michael Reeves surgery robot. It does. But when I see the Michael Reeves surgery robot, I feel like it's super, super unstable. I remember it wobbling. He had his beam, like, the wrong direction. How do I explain it? Give me 1 second while I bring up my drawing diagram. Whiteboards are S tier engineering tool. I feel like maybe one day we'll do like an engineering tool tier list. Because some things are just way better than others. You know? You feel me? Okay. Bum 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 bum. Is it? Huh? Okay. That's good. Another quick moment while I get my freaking... Find my pen for my drawing tablet. Because I'm unorganized as heck. But, like... Okay. So, Michael Reeves, right, like, he had... I mean, the top view, like, looks, like, pretty similar. It's like this... Actually, it was not the same direction. It was, if I remember right, like, the whole bench was, like, a rectangle. And he had the beam that moved was this long beam. And the beams that didn't move, or, like, the rails that didn't move were, like, the short ones. Which automatically, if I remember, this is if I remember it. I might be misremembering. But automatically, moving this really long-ass beam, right, back and forth super fast, of course you're going to end up with it like wobbling, right? Because it's a really long, like, slim beam, so it's going to have really high deflection. And then the other thing that he did that I think caused it to be really, like, suspicious, especially because, like, if you look at it from the side, right, you have, like, the beam, the long-ass beam, and it was, like, this big mounted, like, knife thing. I guess we should look at the video later. It was a big, heavy, mounted knife, and a really important part for the surgery robot is it had to go, like, up and down, right? For it to go up and down with this big-ass weight, like, of course it was flopping, you know, drooping and whatnot. But how he could have fixed it is, like, if you looked at, like, the cross-section of the beam, they're, like, rectangles, right? He had the rectangle, like, flat like this. And so all the weight was, like, pushing down against... Think of, like, paper, I guess, right? If paper is flat like this, it's going to droop, right? But if you put it more vertical, if he had done it, like, in the vertical orientation, it probably would have drooped less. But anyway, that's me going on my complete tangent of how he made, like, some small mistakes. I mean, but he did a pretty sick robot. We should look at that after these. Sorry. Talking about silly tangent stuff. Oh, muted.
But the gantry beam moves down. But if I move one of the motors less than the other one, they only partially cancel out, and the beam and the cart move together. If I move the belts in opposite directions, they both push in the same direction on the cart, and only it moves. By coordinating the motion of both motors, we can move the cart anywhere we want with 2 stationary motors. Isn't that awesome? This belt
cool.
arrangement is called Core XY. You'll see it used a lot in 3D printers.
All right, let's see what this thing can do.
And I guess it makes sense that he knows
that
a lot about this stuff, because I don't know if you guys know, but he used to work for, like, a 3D printer company. So, like, the fact that he's so knowledgeable about this framework for motion, I think it's called, like, kinematics or something like that. It's, like, stuff he worked on professionally, because he has a lot of stuff that moves, like, sort of like this.
Not sound good. Let's try again.
Yeah.
These motors are so powerful that they're making the belt skip. I made some tweaks to the design that have made the problem a lot better, but I'm still not able to use all of the motor power. It's totally fine for now, but if I do want more speed in the future, I'll have to make some more modifications so I can get all the power out.
All right, we are now moving pieces. We're at least 20% done.
Oh,
Somehow the robot needs to pick
thought the
up
belt
every
snapped
piece of
for
the
a second.
puzzle, scan it, and store it somewhere for future use. For now, I'm gonna just feed the robot one piece at a time, and even doing it this way turns out to be pretty challenging. Even if I have something like this so that the robot knows basically where the piece is, I can't just pick it up in the middle because some pieces the suction cup can't get a seal on it. Somehow the robot needs to know the sweet spot for a given piece to pick it up. This is a camera pointing down so that the robot can find the pieces.
When it sees a piece, it calculates the point on it that's furthest from all the edges. This is the best place to pick the piece up because it has the most room for the suction cup.
this isn't
I
even
want
stuff
this
I would have
robot
thought
to work
about
with
when
any
building a
puzzle
robot
with
like
any
this.
pattern on the top. which could lead to some situations where the pieces blend in with the table, which would make them very difficult to pick out with the camera. And so what I'm gonna do instead is pick them up off of a light.
The bright backlight will make every piece look like a black on white silhouette, which is very easy to reliably process.
Ooh, it's so bright.
The robot's taking
It's
pictures
so
of the
bright.
puzzle pieces to figure out if they fit together.
For this to have any chance of working, accurate measurements are critical, which is a lot easier said than done because most camera lenses give a distorted view of the world. Do you really think my face is this shape?
Wait, hold on. I just realized, did you guys see... Did you guys see it all when I was drawing? I don't think I switched my OBS view. This is awkward. Oh, you did? Okay. Whew.
If the computer used this picture of my face to figure out its shape, it would think it looks like this. I have this grid paper that I know is square. I can take a picture of it and see how the lens distorts it.
So
Scared
this
me
is
for a
obviously
second.
wrong. And if we measure how a lens distorts the image, we can actually correct for it by distorting it in the opposite direction.
But this only corrects one of a few problems.
So I have this part that's a bunch of little pillars. And even when it's pointing straight at the camera, you can see the sides of the pillars. And the same thing happens for a puzzle piece. If the back and sides are similar colors, it can be almost impossible to figure out the actual shape of the puzzle piece. This happens because the camera sees everything with a field of view. As this line goes from one extreme of the field of view to the other, everything it touches, the camera will see. The wider the field of view is, the worse this problem
God,
is.
the graphics
If we
are
move
so
the
good.
camera far away and zoom in, the field of view gets smaller and these problems get a lot smaller. And if we take this idea to the extreme and move the camera infinitely far away, the problems disappear.
Getting the camera infinitely far away is challenging, and I'd rather not attempt it, but we're in luck because there's a special kind of lens that sort of does this. This is a telecentric lens, and it sees things as if they're infinitely far away. You can think of it as seeing a tube that comes straight out of the lens that doesn't get any wider. It's really weird.
Now we can move this piece anywhere in the view of the camera and we don't see the sides. It's also always the same size regardless of how far it is from the camera.
The camera's mounted below the table, looking up through a hole, and the robot can bring a piece over the hole and it'll take a picture of the bottom of the piece.
Assembling puzzle pieces is a delicate operation. If you're off by even a millimeter, they don't go together.
For this to work, the gantry has to be very accurate. And unfortunately, I can tell just by looking at the gantry that it's not accurate. And if you can tell by eye that it's bad, it's really bad.
Let me show you what I mean. If the robot's accurate, this will be a 600 millimeter square. Yeah, that's definitely not a square.
Ooh.
Instead of making it nice or tweaking it endlessly to make it better, I'm just gonna fix it in software.
You may have seen me using my OptiTrack cameras in some previous projects. If you haven't, it's a set of tracking cameras.
Mr. 8, I actually don't think he has, like, my understanding is Stuffmadehere, this guy, he basically does all the engineering himself. Actually himself. Which is kind of crazy because of the amount of work that goes into to a project like this. But I've never seen him really interfacing too much with anyone else. And I think if there were other people involved, he probably would mention it. I mean, it's possible he has people helping him, but I'm like 80% sure the engineering is almost completely done by him. Oh, he loses a lot of sleep, mystery. That's my understanding. Is he does not. He works really, really, really hard.
Cameras that can very accurately track the
he's very
location
smart.
of reflective markers like this. If you want to understand how they work, check out my wall painting robot video where I go into more detail.
Putting a marker on the gantry allows me to track its position very accurately. And then if it's going to the wrong spot, my software can correct it so it goes to the right spot. All right, take two. All right, now that is a square.
Is that like? I feel like his control software, like that's what it would be. It'd be like a control system that gives feedback to like adjust and fix it. I would have expected it to really slow down the movement, but it looks like it moves.
This is pretty cool. You can see
at
it
the
moving
same
the gantry
speed.
to the side to correct for the non-square motion. All right, here's a big problem. The gantry accelerates very aggressively, which can shake the whole table.
which can make these pieces wander around. And if the pieces move from where the robot left them, that's a huge problem. The first thing I did is I made the legs super stiff with these tension steel cables.
This should keep the legs from flexing and acting like springs. The strength difference of a couple steel cables is so huge, I have to show you a demo.
This is a model of 2 of the table's legs without bracing, and this is one with bracing. You can see how much this flexes with me barely pulling on it. When you add the bracing, it's not going anywhere. I could probably hang from this if I could find a way to rig it.
What I'm surprised about though is one of his older projects. Ooh, yeah, okay. One of his older projects. What he had like a similar issue where like he was moving a big weight, like, you know, and it was causing shaking because you're moving like the center of mass, and that has like, you know, feedback forces on like the frame that's holding it up. And what his solution for that was he had other weights mounted to it that like whenever the big one would move this way, they'd move the other way, and so the center of mass wouldn't like change. And I thought that was like a really cool way of dealing with like shaking, because I feel like if your solution is just, you know, you make the table more rigid, what happens if like the table's not, you know, firmly mounted to the ground, right? Or, you know, because then it's not even like the legs shaking, it's like the whole table's like shifting. But if you do this, right, you do this thing where like nothing needs to shake because the center of mass doesn't change, then I feel like it would be a lot better. You just don't have to worry about it like at all. More treating like the actual problem as opposed to treating the illness, not the symptoms, I guess. Maybe the words? I don't know. But I think that would have been a cooler way to deal with this.
All right.
Such a huge difference.
The tension cables help, but I'm not convinced that the vibration problem is totally fixed. And I need to be sure, because if the pieces move around, it's game over. So what I did is I made the table hollow, and if I need to, I can drill a bunch of holes in the surface of the table. And then this super powerful vacuum will suck all the air from the inside of the table, which will pull air through all the holes drilled in the top, which will suck the pieces down to the plywood surface so that they can't move around. For it to work, I need about 30,000 holes. I made this little drilling attachment that can attach to the robot where the suction cup would go, and instead of picking up pieces, it will drill holes into itself.
I'm not gonna do this just yet, but if we need it, we've got it. We've got ourselves a little bit of a space dispute. Before the puzzle algorithm can solve the puzzle, it needs pictures of all the pieces. This means all the pieces need to be scanned into the machine. And if I just set the pieces on the table, there's not enough room to assemble the puzzle.
I thought about just making the table bigger, but it's already huge.
And then I thought the robot could make little stacks of pieces until it's ready for them, but any vibrations will knock those stacks over. So I'm making a little magazine that the robot can store the pieces in off to the side. It will basically be a little platform that I can...
The counterweights have to move in 2 dimensions? Yeah, I think that's true, but you could do 2 counterweight systems. I don't know. You're probably right. I just remember in like he showed the clip of the wall painting robot earlier. He was using the counterweight system there. And that was like the whole system was hanging, so it was very, very sensitive, very sensitive to motion. And he it was painting the picture on the wall, so if it was like even a little bit off, it would like really mess with the picture. But he made it work, so I don't know.
Raise up and down with a screw. Whenever the robot sets a piece on the platform, it'll lower down a little bit and then be ready for the next piece. The only problem is that stacking 5,000 puzzle pieces is 35 feet tall. So I'm going to make a bunch of shorter magazines in a row. I'm making the magazine out of polycarbonate. This will let me see what's going on when it jams up. I wonder if it would be possible to design something with more parts than this. I really should have just made the table bigger.
Jeez.
The design for this is kind of weird because I didn't want to have 21 motors driving on the lead screws. It would be expensive and a huge pain to wire up. And if you think about it, you really only need to move one at a time. There's only one robot. And so what I did is I put a single motor on a rail that I can move back and forth to any of the lead screws and turn whichever one I want. We do need a second motor to move the first motor around. There are some tricky little details to ensure it doesn't jam, but I think this design can be reliable.
Yeah, Rax, this is crazy. Like, even any one singular part of this whole project would be like more than I could do, right? Even just this system of these like multiple elevator tracks for holding the puzzle pieces would be a huge effort for me. But I mean, I guess if you've got the big brains and practice like he does, and you're spending, like, this is his full-time job, right? He must have made a ton of money in his previous work, and now he's basically just doing this with all his free time, or all his whole days now as a professional content creator. But like, did you guys notice?
For one I want. We do need a
notice
second
how,
motor to
like,
move the first
precise
motor around. There are some
this
tricky
is
little
done?
details.
Even when it spins, right? It spins enough to put all the like little knobs for these spinners
To
like
ensure it doesn't
back in
jam,
line.
but I think this
Right? It straightens it out, and then it spins back its like control knob.
design can be
E
reliable.
flat.
Having a single motor that can drive a bunch of outputs like this is called multiplexing.
All right, that's all the hardware. Now we can put it through its paces. The robot continuously scans the piece pickup area. When it sees a part, it calculates the best spot to grab it, and then takes it over to get scanned. The software will calculate the shape and size of the piece, square it up, and then store it in the magazine. Well, that's what it would do, at least in a perfect world. In practice, when you combine this many complicated things, it never works on the first, second, third, or fifth try. I like to call this integration hell, because there's lots of problems and it usually sucks.
Ooh,
What the?
me at work.
But eventually you get
Working
through
on
most of the
work
problems.
problems. What the fuck?
All right, things seem to be stable, so it's time to try out my phase 1 testing puzzle. Here we go. All right, the robot has all the pieces and pictures of them.
The laptop sent everything over to my editing computer because it's a beast, and solving this puzzle, even with only 9 pieces, is super computationally intense. A 9-piece puzzle is taking it a couple of minutes. A 5,000-piece puzzle is impossible without me making it faster.
Also, I don't know why, like, every time I've ever seen a script that like runs at this level, right, where you're seeing like the lines of processes being run in like the command prompt window, they always do the ASCII art. And I wonder, how much time software engineers spend just making these nice little artworks.
A 5,000-piece puzzle is impossible without me making it faster, but one step at a time.
So here's the solution for the 9-piece puzzle. You can see that all the pieces don't line up perfectly.
It
This is
doesn't
one of the
look
things that
right.
makes it so hard to compute.
Once it has a solution, it sends it back to the laptop.
Hey Ash, how are you? We're watching YouTube videos right now. We're watching videos on 2 big engineering content creators have different, puzzle solving machines. So we're gonna take a look at them.
And if I hit enter, it won't do the right thing yet. There's still one more problem.
The assembly plan wants to construct the puzzle from one side to the other in one straight shot.
But these pieces are in a random order. It's just whatever order I gave them to the robot. And so the first piece that it wants is probably somewhere in the middle or the bottom.
I wrote a little routine that'll take the pieces out and then put them back in the correct order.
All right, it's finally ready to try to solve the puzzle. So here we go.
I want chips and salsa, Ash. You better be prepped to share. Me when I'm building puzzles.
Not the best start, but it did put them in a grid. It's better than nothing.
Let's try again.
Not the best start,
They're not
but
even-
it did put them in a grid.
Guys, the corner pieces don't even have the corners facing the right way.
It's better than nothing.
Let's try again. Think it might be better. All right, this time's the charm. Maybe I should pivot and make this robot an avant-garde puzzle solver. All right, let's try again.
Modern art.
It's definitely got the right idea. There's just some problems still. All right, this one's the one. All right, maybe not.
It's getting so, like, seeing
well,
it
you
get
haven't
better
seen
is
all
so
the software
pleasant.
I've been going through. All right, this last time. Yes. Come on, baby. One more. Just one more. Yes.
Oh, Mystery, he does a really good job of
Yes.
always showing every
One
failure. Like,
more.
all his videos always include
Finally.
integration hell.
What a pain.
And I think it's really good
Oh,
because, like, you
That
look
was
at
3 weeks of work.
all the other content
I know
creators,
it's
and I
only a
don't
3x3,
feel like
but
you
it's
get
so
a
cool.
good sense
And
of
I
how
think
much
that's
failure
because
goes
so
into
much
engineering.
has to go right to even do this that it's amazing
so
to see
good,
it all come
though.
together. This is a very highly abridged version of the struggle that it took to get this thing solving even the 3x3. All the algorithms to take the
Ash, this is supposed to be any puzzle.
pictures of the
I think.
pieces and then solve the puzzle is doing an enormous amount of work. I spent over 3 weeks on it, and there's still a lot more work to be done before I can do a 5,000 piece puzzle. The algorithm is so slow that it would take about 3,000 years to solve the puzzle. So instead of just grinding through the software issues and then glossing over it like I normally do, I want to take you deep inside the matrix. I want to show you how this thing actually solves puzzles and how
Into
I made
the
it fast.
matrix.
Or at least how I think I'm going to make it fast, because it's super interesting. So all of that's going to be in part 2. So if
Okay.
that sounds interesting,
I
please
forgot this
consider
was a
subscribing
two-part
so you don't miss it. And before we go, the wife is going to come over and we're going to do a slightly bigger puzzle than a 3x3 for game night. If seeing all these projects get you super amped up to go out there and learn and build stuff, you should take a minute to check out this video's sponsor, Brilliant. I admire Brilliant because they're doing something very important. They make a tool that makes it so much easier to
Is
learn
it rude to
complex,
skip
important
people's
stuff.
ads when
They'll
we're
take a
watching the
topic
videos?
like learning
if
to
we're doing
program
reviews?
Python, and they'll present it in an interactive,
Max,
hands-on way
he said
that has you
3
writing
weeks.
actual code
I think
in
that
the
was
lesson.
3 weeks of
Hands-on
just
learning by doing
the little
is an
bit of
extremely
integration
effective
hell.
way to learn.
I
and it's
suspect
so much more
this
than
was
Python.
way more
Look at
than
all
3
these
weeks.
courses, all
Or
the
at-
math.
I suspect this was
physics,
probably like
computer science,
a month
stuff
and a
that
half
you
to
thought
2
you had to go to
months.
college to learn.
But I don't know for
Nope.
sure.
They take these big, intimidating subjects like vector
Maybe I'm wrong.
calculus, and they divide it up into a bunch of bite-sized pieces that build one on top of the other, which is really good for learning a bit every day. This is how I've learned a lot of what I know. I try to spend at least 30 minutes a day learning something new. I know
I
I've
wanna
said it a bunch
skip
of
it,
times, but it's amazing
also-
how much you learn
I'm
when you
basically
exercise your brain
stealing
regularly
his
like this.
content.
I've been
by
working through the
doing a
course on
VOD
quantum
review of it,
mechanics
so
because I know nothing about it, at least
we'll
not
give
yet,
him-
and it's been super interesting. So
give
if
him
you
the
want to learn
mini
a bunch
ad
of interesting new stuff
review.
that's going to level you up
Brilliant
and
does
make
seem
you more
like a cool
capable,
company, though.
go check out Brilliant. All you have to do is go to
Brilliant, sponsor me.
brilliant.org/stuffmadehere. You can sign up
Sponsor
for
me.
free, and the first 200 people that do this will get 20%
Me and
off
my
their
whole
annual premium membership.
7
Finding ways
viewers.
to always be learning new stuff is one of the best things you can do. So I hope you check out Brilliant, and that's it. Thank you, Brilliant, for sponsoring this video, and thank you for listening.
Okay.
This thing is so cool. Isn't it great?
I mean, it's neat, but we're not even doing anything.
It gets better. This is probably going to take about an hour and a half.
Really?
Yeah.
Why?
Has to think really hard.
She's like, what? Why?
See
They're
why
sitting
I need
there.
that?
Watching you. Guys! The ASCII art. There's no escape from the ASCII art.
Oh, shoot. It's already done. It's way more fun when you actually see it solving the puzzle.
And maybe if it had more pieces.
His wife roasting him. Okay, I forgot this was a 2-part video. Let's do... Where's the other one? Here we go.
How long do you think it would take you to solve a 5,000 piece, all-white puzzle? I think it would take the average person a really long time, like years. But I think that a computer...
Rax, is that what you're telling the ladies? This is average size. I promise.
and a robot can do it really fast, like
Classic.
less than a day, if I can get my robot working. In my last video, I made a robot that can assemble puzzles, but it's real dumb. It couldn't do more than maybe 50 pieces. So ever since, I've been working on an algorithm which will hopefully allow the robot to take big puzzles with like 5,000 pieces, figure them out,
It
and
wouldn't
then
work,
assemble
Ash.
them
I couldn't do it.
quickly.
We could
All
try.
white puzzles are really hard because there's no picture that you can look at
We
to
could try.
figure out if pieces will fit together. If I want to figure out what piece connects to this piece, I have to pretty much pick up every single piece
But these guys
and
are so
test
much
it
better
to see
than
if
I
it
am.
fits. If you do the math, this works out to somewhere around 30 million comparisons that you would need to do, and that's why I say it should take a human years.
I wanted to do this project because I love seeing robots do something that's hard for humans, and I also really wanted to talk about
He does
computer
such
science,
cool projects,
so I get
guys.
to do both.
Here's my plan for solving the puzzle. I'm going to give the robot each piece one at a time so that it can get a picture of every piece.
And then it will extract the shape of every piece from the photos, and then think really, really hard about all the ways that it could assemble it until it finds the right one, and then it'll use that plan to actually assemble the puzzle.
When you list it out like that, it doesn't sound that bad, but I've spent the last several months trying to solve this problem. It is without a doubt the hardest project that I've done, but it is an awesome opportunity to
Several
talk
months.
about
I'd
algorithms
only
and
just processed with
software.
me.
It's the reason that I did it, so let's get into it.
I made a few
Several
hardware
months of
upgrades since the
programming.
last video. It's better, faster, stronger, less breakable, but I'm not going to get into the details of those because I want to focus on the software. So the key takeaways are, number one, the magazine is gone because it is a reliability nightmare. And I made some upgrades to the business end that limit the range of motion of the robot, and it can't physically assemble my 5,000 piece puzzle anymore.
So I was thinking about it a bit more, and 5,000 piece puzzles are totally overrated. What will be really hard is a 4,000 piece puzzle.
Move
No one
the
makes a
goalpost.
4,000 piece all white puzzle, so I got a normal puzzle and I painted it white. With all that done, all that's between us and a solved puzzle is our imagination and a lot of software. Except I forgot my lease is up on my shop, so I have to move all of my stuff.
He also moves
This took
shops
me
like
so much longer than I was expecting.
every year.
Like 6 weeks to move everything, clean up all the damage at the last shop, and get set up at the new place. Moving a very delicate puzzle-solving robot is nerve-wracking, but I only slightly broke it.
Welcome to my new workshop. There is a lot of stuff. It is packed tighter than a neutron star. What it doesn't have is a lot of room to
Fancy
do
science
stuff,
words.
but that's okay.
Because I have shipping containers that are packed. Very, very
my
packed. All right, let's get back to
The
the
Christmas
robot. The first step
decorations
to solving the puzzle
hidden
is getting
amongst
a
all
picture
the
of every
all the
piece.
engineering tools.
I'm going to give the robot each piece one at a time.
It'll take a picture of each piece with this very accurate camera with a telecentric lens. This takes about 8 hours. Thank goodness I only have to do it once.
All right, so I've got 4,000 pictures of all the pieces, but that doesn't really do me any good. I need to extract the shape of each piece from the photos.
Here's how I do that.
Also, can you? I didn't expect he'd be doing it by hand. Can
Alright,
you
so
imagine like
at a
hand
time?
feeding the robot?
It'll take a picture of each piece with this very
For
accurate
4,000
camera with a
pieces?
telecentric lens. This takes about 8 hours. Thank goodness I only have
Yeah, Mystery. He does have like he has a video that's sort of a shop tour, and what he does is he builds a projectile launcher using each of his machines. So he has like a machine that he builds. I think it's like a crossbow out of sheet metal to showcase the sheet metal like cutting and bending machine. He builds like a little catapult using a 3D printer to showcase his 3D printer. He builds a different form of catapult to showcase what his mill can do. You know, he does have like a showcase type thing. Yeah, Rax, he's a hoarder just like me. I will also one day hang up all my posters from AX, but for now, they're sitting on the floor where my kitchen table used to be, because I had to move my kitchen table to
to
make
do
room
it
for
once.
this.
All right, so I've got 4,000 pictures of all the pieces, but that doesn't really do me any good. I need to extract the shape of each piece from the photos.
Here's how I do that. Each picture is made up of a bunch of pixels that have a color, and the
Ugh.
pixels showing the background are a very different
The
color than the
pixelation.
piece. We can
Gross.
say any pixel that's similar to the color of the background isn't the puzzle piece, and every other pixel is the puzzle piece. So we've got a blob that's the shape of the puzzle piece, but what we really care about is the shape of the edge. because that's what does all the connecting. So the next step is to extract it. So all we need to do is look at every pixel that's in the piece. If that pixel is next to a background pixel, we say that pixel is part of the edge. And if you do this for every pixel in the image, you get the entire edge of the piece. So at this point, we can throw away the image and treat the pixels as points in space that form the edge of a complicated polygon. We want to do this so that we're not constrained to pixels.
When you think about solving a puzzle, you're usually not thinking about the entire shape of the piece. You're thinking about the shape of one of the sides. So we need to take this perimeter and divide it into the 4 sides for the puzzle piece. And once we have those, then we can start seeing which ones might fit together.
Conceptually, this is
It's
pretty
so
easy.
enlightening,
You find the corners of the
seeing all this
piece,
stuff.
and you divide the contour up at every corner. But in reality, it's pretty tricky. If we zoom in on the corner, it isn't perfectly sharp. Any point along this curve could be considered the corner. If I'm not rigorous about how I define the corner, some edges will appear longer or shorter, and they will not match correctly. I start by finding the approximate corner locations, and then I grab a little part of the polygon on each side of this corner, and I fit a curve to it. I consider the intersection of these 2 curves the corner of the piece. And it
Oh my
usually
God, I
doesn't
forgot
fall
how
on the
much goes
polygon.
into this.
So we find the point on the polygon that's closest to this corner floating out in space, and we split it in half at that location. If you repeat this for every corner, you get 4 curves that are the shape of each side.
I'm going to calculate this for every piece, and it's probably going to take a while, but I only have to do it once. I can save the result to my hard drive and then load it way faster than it would take to calculate it. This is sometimes called pre-processing. So this is going to take a lot longer than I was
The
expecting.
ASCII is
like
everywhere.
probably days. Times like this make me really glad to have a super powerful computer, because
Here's
instead
a
of trying to
sponsor.
make it faster, I can just throw more computer at it and it'll hopefully be fine. So what I'm going to do is split this job into 80
Oh,
smaller
not
jobs
sponsored.
that I'll run at the same time. So hopefully instead of a few days, it'll get done in a few hours. I don't think I've ever talked about my computer before,
Oh,
which is
maybe
kind
it
of
is
surprising
sponsored.
because it's my most important tool. I've had this thing for about a year. It's made by a company called Puget Systems, and it is a beast. They asked me what specs I thought I needed, and I said I need all the RAM, all the CPU, and all the GPU. And for stuff like poorly written programs, big CAD assemblies, and editing videos, it is astonishing how much time it saves me. If you're looking for a beefy, reliable machine, you should check out Puget. I'm a big fan. I know a lot of people are going to tell me that I wouldn't
wonder
have these
how much it
problems
costs.
if I didn't write my code in Python. But if I wrote my code in something like C++, I would still be writing code. So I like this trade.
I'm all done, bro.
Now that we know the shape of all the edges, we need to go through all of them and figure out which ones potentially match. The slow, easy way to do this would be to compare every edge to every other edge, but that would be too slow.
This is where we get into software optimization. You may have heard people talk about this before. The general idea is that you find some kind of shortcut or alternate way of computing something so that it goes faster. And what we're going to try to do is find a way so that we can directly compute which edges match a given edge without
many
having to
different
do any
languages do
comparisons.
you know, Ash?
So if I have an edge, I can just directly say, here's all the edges that are similar.
Guys, what? Bets on what his hidden message here will be. The fact that it starts with "I'm." Make your predictions now. He always has these like hidden memes on his like third monitor.
Similar to that one without having to compare it to every possible edge. It's gonna get kind of weird, but also kind of awesome, so hold on to your butts.
We can start by grabbing one of our edges and making an imaginary line from one
What
side
is
to the
Ruby?
other, and then divide this line into
You're
some
a
number
Ruby.
of equally spaced points. And then at each point, we calculate how far the curve is away from the line at that location. This will give us a list of numbers that approximates the shape of this curve. To make what we're about to do easier to understand, let's pretend that we only took 2 evenly spaced points. If I treat the first number as an x-coordinate and the second number as a y-coordinate, we can plot this point on a 2D graph. If we do this for a bunch of edges, ones that are similar will be near each other on the graph, and ones
Guys,
that
this
aren't
is such
similar will be
crazy,
far
like,
apart.
thought
Unfortunately, figuring out what points are near a given point requires that we compare them, which is what we don't want to do. So we need to go deeper. If I take a line and add it to this graph, we can calculate which side of the line any given point falls on. Then if I get a new edge and I calculate where it goes on the graph, I can see which side of this line that it falls on, and I can ignore any of the points that are on the other side of the line. I know that it's not going to be similar to them without having to compare it. But this stops being effective if I have points all over the place. But if we add more lines dividing this graph, something really cool happens. This point is on the left side of this line, the right side of this line, and the left side of this line. This sequence of left, right, left describes a very small, specific region of this graph. And all the other regions have their own unique sequence. So for every point on this graph, we can calculate the sequence that describes where it is on the graph. If we keep track of what region of the graph each point falls under, if we get a new edge, we can just calculate where it falls on this graph and directly look up what other points are similar without doing any comparisons.
So I did this in 2D so that we could visualize it. I used 128 dimensional space for my hash. The math is
This man just said 128 dimensional space like it was nothing. He didn't even bat an eye. He's like, yeah, 128 dimensional space. Fuck.
is the same. It's just a 128 dimensional graph, and instead of a line, you're a hyperplane, but the math is really the same.
A hyperplane.
You just can't visualize it. And I did not invent this. It's called locality sensitive hashing. It has nothing to do with crypto or medicinal oils, and it is an amazing technique. One other really
Oh, here's second word. First word was I'm. Second word is slowly.
cool thing that it's used for is reverse image search. We're going to use the hash to find all of the similar edges for all of the pieces. I've been looking at this forever, for days.
Oh, wait, you guys are already off. It's totally. Wait, I'm slowly totally. I feel like that's too many adverbs.
And I initially thought that I did it wrong, which is usually a really good guess. But in this case, it's even worse. It looks like I did it right, but it's still giving me the wrong answer. It looks like we've got a bad case of what programmers call garbage in, garbage out.
When this happens, it doesn't matter how good your algorithm is. If you give it garbage data, it's going to give you garbage results. Although in my case, it's very subtle
The
garbage.
poop emoji.
It's like a tiny bit of dog poo in your brownies. You wouldn't know it from just looking at it,
Guys,
but it's garbage.
Guys, why did he have to say dog poo
They
and
must
brownies?
have
That's
used a
so
very
gross.
dull knife when they cut out the pieces. The edges are super fuzzy, which makes the pieces look like a different shape than they actually are.
I feel also like when the issue is that your pieces are too fuzzy, it's probably not like... I feel like at that point what you want is actually you want less precision, right? You want to sort of like zoom out so the fuzziness goes away is what I feel like. But
This thing
maybe
is
that's
a
not right.
vibratory bowl tumbler, and the way it works is there's abrasive grit inside of it, which it vibrates really hard. And if you have something that has a lot of rust on it or
Vibration.
sharp edges, you can throw it in here, let it run for a few hours, and when you come back, you have a really beautiful part. So this thing is usually used with metal, but I'm hoping with some very gentle abrasive, I can put cardboard puzzle pieces in there, and they won't get disintegrated into nothing.
I feel like they're totally gonna get disintegrated into nothing.
All right, this is approximately
maybe not.
infinity times better. All of the pieces changed, so we have to scan them in again. This takes about 8 hours. Thank
Why
goodness
does
I
he
only
do
have
it
to
by
do it
hand?
twice. All right, let's calculate all the edge matches.
The fact that he has to do it by hand is awful.
All right, I am gonna lose my mind. So the pieces look good. My code looks good. The results don't look good. Upon closer inspection, it looks like the vibratory tumbler did a great job of removing all of the little fuzzy things and sharp edges, but it also did a good job of changing the shape of the puzzle pieces by grinding them down. And when you take pictures of them, they don't look like they fit together anymore, which
His
I guess that
photos are
makes
just
sense,
too precise.
but it is really
When you're worried
unfortunate.
about the little
This
fuzzies.
is a really annoying problem. Even if I go and buy a higher quality puzzle that doesn't have the rough edges, if I paint it white, I'm gonna get paint on the sides of the pieces, and I'm gonna wanna put it back in here, and it's gonna mess it up again. The only thing I can think to do is make my own puzzle. I can get the top of it painted white, and then I can cut a puzzle out of it. It'll have really nice clean edges, and there won't be any paint on the sides.
I should have done this from the beginning. I would have saved so much time. It's a
It
new
does look
puzzle,
really
so I
clean,
have to rescan it, which takes about 8 hours. Thank goodness I only have to do this 3 times.
I didn't realize it when I was making it, but my laser cut puzzle has some self-intersections on the contours, which
Rest
turns
in
one
peace.
piece into one really messed up piece in an extra little chunk, and it looks like there's only 4 of them.
It's
I
gross.
could spend a bunch of time updating my algorithm to support malformed pieces, but that really seems like a dumb idea. I could remake the puzzle, but that would take me like a day. I'm really leaning towards option C, which is just put the pieces into the 4 missing spots when the puzzle's done. All right, we got new picks.
I'm slowly wait, did he say going somewhere? So far I saw I'm slowly totally insane. Did I miss a
New hash.
miss a word?
3rd time's the charm.
Okay, finally. Believe it or not, we are just now getting to the crux of this problem. Every side of every piece potentially connects to multiple other pieces. And without any kind of picture on the puzzle, the only way to know which of these edge connections is the right one is to build more of the puzzle and see if it makes sense. If we go back to that original piece, it has some number of potential connections on each side.
Oh,
if
did we-
pick
was
one of the
there going?
possibilities for each of these sides, the only way that they work is if they share a mutual piece in between them, like this. Otherwise, there's no way to connect them. So even if they fit well to the original piece, they don't make sense when you consider the rest of the puzzle. If you do this for every piece, it reduces the number of possibilities dramatically. Incidentally, doing this also generates all of the possible 2x2 squares of pieces that you could use. And this is where we go deeper. We can pretend that a 2x2 block of pieces is one big complicated puzzle piece. If both of the pieces on this block connect to both of the pieces on another block, then it's a valid connection. We can eliminate possible
So
adjacent
cool.
block unless they share a mutual block. And then you can build 2x2 blocks of 2x2 blocks, which would be a 4x4 block, and then keep repeating this until you can't go any further.
This part is actually really mind-bending.
Top vacation spots with no robots, guys. No robots. He's sick of them. I guess if that's what you do, for work, that's not what you want to do for vacation time, right? Like too much of anything just becomes too much. But his memes are so hilarious on his 3rd monitor. He's got good meme game. Also, rest in peace ads. Rest in peace ads. But I guess while ads are going, I will say something that, like, he was talking about his, like, little methodology for, like, quantifying pieces, right? Where they're, like, you have your curve, right? That might look like that. And you compare it to, like, a straight line between the endpoints, and then it's, like, how far is it from the straight line? It's short here, long here, long, you know? I feel like this is, like, what do you do here when there's actually 2 different points, right? And, I mean, don't you end up with, like, a lot of ones that look very similar? Oh, shit. Sorry, I should... bad streamer moment. Okay. Let's refresh. Oh no. What's the game plan? We'll do this one set to really large and white. Larger than this. Larger. Okay. But anyway, back to like my question is, like, he was talking about, like, you know, characterizing pieces by, you have, like, the line, right? The border of this piece and the next. And you, like, compare it with what would be a straight line from the endpoints. And you're like, how far is it from this line? This is, like, really short, so that's a 1. This is, like, significantly longer, so this might be like a 6. This might be like a 10, right? And so on and so forth. But in these chunks, how is it that you choose to measure from this point, or this point, or this point, first of all, right? And second, I feel like you end up with, of course you can take like lots and lots and lots of points, but that seems maybe inefficient. But I feel like you'll end up with a lot that look relatively similar, right? This will have a similar value here to one that looks like that, right? And then it maybe doesn't give you the results you want. I mean, I know ultimately the answer can just be like, oh, we just take way more points. So we take 200 points, and then we just hash it here, like everywhere, right? But that seems like a huge waste of computing power. I don't know if I think this is the right way to go about this. But that's just me, like, I don't have a good way to go about this. I'm just, classic Breakabout things is like, I point out problems that I don't have solutions to. Just like at work. But yeah, I mean, that's what I was thinking when I was seeing his, like, methodology here. It's like, I don't know if this is the right way to do this, but it seems like it works well enough. Anyway, back to the video. I think the ads are done.
And really annoying. I spent several weeks at this stage. I could not get it to fully complete, and I did have to give it some hints to help it along. I do think with some more time I could have it run fully autonomously, but I'm fine. I'm okay with that. So at the end of this process, most of the pieces only have one possible connection. So then you can go through that and assemble the grid of all the pieces, which the robot can use to actually solve the puzzle. 4,000 pieces is a lot of pieces, and it is not very fun to feed them in one by one into this robot. I did want to have an automatic vibratory bowl feeder. I even built one, but it had a bunch of issues, and I figured it would take me longer to fix those issues than it would take for me to feed all the pieces in, and so I'm just going to do that. Thank goodness I only have to do this 4 times. One other big problem that I really wanted to solve, but I just don't have time for, is that sometimes when you put pieces down, they won't fit together perfectly. This sort of has a cascade effect. When you click 2 pieces together, it'll shift the pieces that it's connecting to, and then when you try to connect a piece to the shifted pieces, it'll get tilted and won't seat all the way down. And I wanted to be able to scan the pieces that I put down, which is why I have this other camera. That's why the table's orange, so that I can very clearly see the pieces that I put down. And that's why I added this really nice light to the camera.
Worth of money.
If it can put them in mostly the right spot, and I just have to nudge them with my finger to make them click together, that is a complete win by my book. So one thing that I like to say is that if at first you don't succeed, reduce your expectations until you're a success. I think those are pretty good words to live by, and that's definitely what I'm doing here. At least in theory, the robot now has everything that it needs to solve the puzzle. If I put it into solve mode,
the robot expects me to load the pieces one by one. When it sees a new piece, it extracts all of its details, and then looks up where it needs to go using the solution. And then it rotates the part to whatever orientation it needs to be at, and then moves over and puts it down where it needs to go.
All right, here we go.
Let's go!
That is so satisfying. All right, well, with this many pieces, you can't expect them all to fit together, right? I already regret not making that feeder bowl work.
Guys, I'm already predicting right here, where you see the pieces are not sitting flat. Catastrophic disaster. Catastrophic disaster is going to happen. The arm is gonna skim over and it's gonna shift all the pieces. And everything's gonna break. Oh, maybe not. Oh.
I didn't see it happen, but I think a piece stuck up just barely enough to hit.
Wrong spot.
I was able to get it mostly back to the right spot, I think. I was gonna wait until the end to push the pieces down, but that crash has me paranoid. The cumulative error is really adding up in some spots. The pieces are in the right spots though, so it's an easy fix. Well, except for this last row, there's
What?
a bunch of pieces that do not belong that are being stacked on top of each other. I'm
How is it
guessing this is
stacking?
a stupid logic error, but I'll have to look. It was a stupid bug. I think it's fixed, so let's keep going. All right, it's almost there. Just gotta seat these pieces.
I have no idea why, but only on this edge of the puzzle, some of the pieces are not put in the right spot. They're stacked randomly on other parts of the edge, mostly this edge. This is the last row in the simulation. I'm guessing there's still a kind of stupid bug happening there, although I looked at the code and there's nothing really obvious. So
It's
I thought
never
about
obvious,
spending
though.
a ton
Actually,
more
I guess
time
sometimes it is,
trying to
but-
get to the bottom of this, but I could also just do this. I don't think anyone would know or even care, right?
We know.
There's a few other missing pieces. This is where the messed up self-intersecting pieces would be. So we can just put those in the right spots.
All right, it is done. I made this puzzle, yet somehow I lost 2 pieces.
Ugh.
I could laser cut some replacement parts, but I think there's something poetic about 2 pieces being missing. It sort of matches really well with my reduced expectations, and the journey was the destination in any case, and I hope that you enjoyed it. I hope you learned something about algorithms. If you find this fascinating like I do, you should consider becoming a programmer if you aren't already. It is an awesome job where you basically explain to a computer in excruciating detail how to do stuff like this. I'm really curious to see if my wife is as impressed with this as I am. But before we get to that, I want to talk about this video's sponsor. It's a company that I think is amazing, Brilliant. People reach out to me all the
Exactly,
time asking
Rax.
me what it is they need to learn to
If
be
you
able to
don't
make
succeed,
stuff like I do.
reduce your
and whenever they do, it makes me really
expectations.
happy because I really want to inspire people. And this is why I love Brilliant. It's a really powerful tool for learning math and computer science and a bunch of other technical stuff. The way it works is they'll take a really complicated subject like computer science and they'll break it down into a bunch of bite-sized lessons which will teach you concepts and then reinforce it by having you work examples, which is just the best way to learn. I've read textbooks for years and this is exactly what I do. And Brilliant is better than a textbook could ever be because a lot of the examples are interactive. It's so much easier to see and build intuition for how something works when you can directly interact and manipulate it. And the fact that they're smaller lessons makes it really easy to do a little bit every day. I try to spend a little bit of time every day doing some kind of learning, and I'm always amazed when I look back at the past year how much progress I make just from that little bit every day.
Really
I've been
amazing
working through their lessons on
encourages
differential
you
equations.
not to learn
I
code?
did learn this back in college, but I never really got
Yeah,
it.
I mean-
and I also forgot everything I knew about them in all the time
Or-
since. And I feel like it's starting to click, which is awesome. So if
Like
you're
me?
interested in building technical skill, you
As
need
like
to
a
check out Brilliant.
multifaceted engineer,
It is an amazing
I really
tool,
should learn
and it's free to get started.
to code
All you have
more.
to do is go to brilliant.org/stuffmadehere.
can't be asked.
You can also click on the link in the description, and the first 200 people to do this will get 20% off their annual premium membership. And that's it. Thank you, Brilliant, for sponsoring this video, and thank you for taking the time to check it out. All right, let's see what the wife thinks. Hey, wife.
Hey, wife.
Wow.
Hey, wife.
I thought you said it was finished.
Ash, hey.
I spend months building these projects and I love doing it. If you enjoy these videos, please consider supporting them. Subscribing to the channel helps me get sponsorships, and you can also support them directly on Patreon. Thanks.
This guy must really enjoy his job. I mean, I know it looks miserable, but yeah, the wife is the final boss, Rax. And his wife is hilarious. All the wife interactions I ever see on his videos are hilarious. Hi, Ash. How was your drink? Hope it was strong. Of course. Of course. it looks incredibly hard, Mystery. Yeah, I mean, software programmers are a different breed, right? I mean, like I said, I think of myself as very multifaceted, right? I'm a systems engineer, so my job is to like know a decent amount of everything. But I cannot code really. Well, I can code, but I don't really know any of the like real languages, right? People ask me like, "Oh, do you have experience?" And I'm like, I do MATLAB." And then they laugh at me and I go sit dejectedly in the corner. But like what these people do is like above and beyond, especially with all like the fancy math logic stuff. I mean, you say that, Ash, but I don't know if I understand that many things. Okay, but at the end, I mean, the moral of the story, Ash, is it was still like, it did a pretty good job. But the machine, you know, still had
I have
some
no
issues.
idea why.
I'm ready to see Mark Rober's. The googly eyes. Alright, but remember also that Mark Rober has like a big team, as opposed to Shane. Stuffmadehere works basically solo, which is already insane.
This is Jigsaw. He's a friendly little robot that's really, really good at only one thing: putting together any jigsaw puzzle, no matter how complicated, really, really fast. It's taken us 3 years to get to this point, but according to our initial tests, we have hopes he might be 200 times faster than the fastest competitive jigsaw puzzler in the world. So today we're gonna walk through what it took to get ready for the ultimate robot versus human face-off, and along the way, we may just discover some tricks you might find helpful as a mere human jigsaw puzzler yourself. But before we unpack how Jigsaw does what he does...
Also, is it too loud? Is the volume good? I sort of feel like I need to turn down the volume, so I wonder... It's not like destroying you guys, is it? Maybe I'll turn down the volume a little. Definitely seems like it's louder than the previous one.
First want to give us humans some well-deserved credit, because while this seems pretty straightforward of me to be able to pick up so before we unpack how Jigsaw does what he does, I first want to give us humans some well-deserved credit, because while this seems pretty straightforward of me to be able to pick up and arrange these 12 pieces of a puzzle, I'm actually doing 4 very complicated tasks. The first is just picking up a piece. Have you ever stopped to think just how amazing our hands are? Hiding beneath that skin are 27 bones and 34 muscles, which makes them flexible and strong, but they're also incredibly precise and dexterous, thanks to the high concentration of nerves in our fingertips for sensing pressure, textures, and temperature. We've also evolved to have opposable thumbs, which makes it way easier to hold tools and to manipulate and pick things up than if it was just 5 fingers all side by side. Step 2 is rotating the piece to the correct orientation, which again is pretty straightforward when you have all the abilities I just mentioned.
Look at it! Look at the squirrel! Look at how fluffy its tail is. Sorry, I'm totally tangenting.
For step 3, we need to move the piece into position, and that requires our whole arm. As I mentioned before, most vertebrae have the same basic arm bone configuration, from a human, to a bat, to a chicken, to a turtle, to a dolphin. But when you include
Ash, is that really what you want?
the hand, our configuration is the most technically capable arm of any living thing to have ever existed on this planet. If you imagine a large cube in front of me, it's wild that us humans can move this puzzle piece to any position and orientation within that cube. That's really hard for a robot, or pretty much any other species to do for that matter. For step 4, we have to decide where this piece should go. And for us humans, it's hard to explain how, but when we look at this, it just very quickly feels super obvious. This piece should go here. What's actually happening though is our eyes communicate visual perception to our brains, which then subconsciously synthesize a complicated combination of pattern recognition, spatial reasoning, visual memory, and executive function. And as a result, in fractions of a second, the right answer just feels obvious.
I want to say
brag, but this is once again where us humans are the undisputed champions. Our complex brains are what make us special. Physically, we're kinda unremarkable in the animal kingdom. We're not faster than cheetahs or stronger than bears. We can't swim as well as dolphins or fly like an eagle. It's our brains that make up 2% of our body weight, yet they consume 20% of our energy every day. And that ratio is higher than any other living thing ever, and it's the reason we're the ultimate apex predators, because it allows for the huge survival advantages that come from tool use, planning, problem solving, language, and large-scale cooperation with other humans. It's also also what has possibly up until this moment in history made us the best at jigsaw puzzles. So if we wanted to make a robot that was as good or better than us at puzzles, our daunting challenge was to take the 200 million years of evolution that enabled those 4 steps and figure out how to translate it into things a robot can do. For number 1, to pick up a piece, in lieu of an opposable thumb and 27 hand bones, we used a tiny specialized suction cup that's often used to manipulate small objects on assembly lines. This solenoid here can cut off and then connect to this vacuum pump, which means we could turn on the suction exactly when we want to pick it up and then connect to this vacuum pump,
Guys?
which means we could turn on the suction.
This is your mom every Friday night. sorry. I couldn't resist.
Exactly when we want to pick it up, and then turn it off exactly when we want to let it go. For number 2, we attach the suction cup grabber of Jigsaw to this very fine-tuned donut motor that's precise to an incredible 0.005 degrees. That means if you attached an infinitely sharp knife to the end of the motor, it could slice your birthday cake into over 65,000 pieces. For number 3, to move a piece around, we modified our Avid
really
CNC
necessary
router
to be
we're
that precise?
constantly using around here for our large builds by upgrading the motors to ClearPath industrial servo motors. These are the same motors we used on the Dominator, our autonomous domino robot. Once we did this, we saw it could accurately place a puzzle piece down to 0.0005 inches. That's 1/10 the width of a human hair, which means, as you can see here, Jigsaw can take the lead out of a mechanical pencil, then move all around the table, and then come back and put the lead right back in.
Okay, but like, I understand wanting the precision to like do the lead in the pencil, right? That's sort of reasonable. But why do we need?
That's
Why do we need 1/10 of a human hair? Right? This is such overkill for a puzzle. I
the
feel
width
like.
of a human hair, which means, as you can see here, Jigsaw can take the lead out of a mechanical pencil, then move all around the table,
It's so
and then
super
come back
impressive,
and
though.
put the lead right back in. So now that Jigsaw can pick up, rotate, and move any piece with terrifying precision, the only thing he lacked was step 4, knowing exactly where to place the pieces. And as you might guess, this was by far the hardest one to solve, because all the subconscious work performed by neural pathways in our brain that handle pattern recognition and spatial reasoning that make finding the right piece feel so obvious to us is a really hard problem to solve using just computer logic and code. To make matters worse, just as we were really struggling to come up with a good solution to this problem, the most devastating thing that can happen as a YouTuber actually happened. My friend Shane from the YouTube channel Stuffmadehere
Got him. This is why Shane's the best.
released a video about, you guessed it, a machine that solves jigsaw puzzles. And what you should know about Shane is he's probably the most technically capable engineer I know. If there are like 15 categories that make you a good engineer, my knowledge goes pretty deep in maybe 4, and I'm a generalist in the rest, but then I have people like Ian and others on my team who help fill in the gaps. Shane, however, is somehow an expert in all 15, which is why you should subscribe to his channel. When I told him he beat me to the finish line, he told me he personally wasn't satisfied with where he landed the project and encouraged me to keep trying. So I persevered, and that's when our fortunes improved. Because while filming a video in Rwanda covering the work done at Zipline, where they deliver life-saving blood using autonomous drones, I got to spend some time with Ryan, their co-founder who's responsible for all their complicated software algorithms. And after hearing all of our challenges, by the time the plane landed on the way back home, he'd coded up a solution that ended up being the backbone that unlocked everything for us. Basically, instead of trying to compete with our brain's very complicated pattern matching neural network, we took a much more simple approach by completely ignoring what was printed on the puzzle and just looked at the edges. So while painting it white makes it more impressive and way harder to solve for us humans, it would make no difference to Jigsaw. So to do this edge analysis, we first needed a set of eyes. Well, not those eyes. Those are just decorative, because it's no secret I love a good pair of googly eyes, and these were our most advanced set of googly eyes ever, because the googly is controlled by 2 servo motors. Jigsaw's real eyes were just a cell phone camera. The idea was to run a serpentine pattern over all the pieces and take a picture of each one and then isolate them against the background, then convert the edges of every piece into 4 splines. So if we wanted to find a match, say for this edge, we would just need to take that spline and then find the puzzle piece that had a corresponding edge spline that matched up perfectly.
So this is like really interesting because how different it seems from what Shane was dealing with. Like Shane had this like really elaborate, like you needed to eliminate like the angle that the camera viewed it at with that fancy lens, right? And then he was doing all this like crazy math on these, and I'm sure there's still math here, but this seems like it seems like they took a much more simplified approach here. Which, I mean, I think is probably good. I think generally you want, like, simpler solutions are easier to execute, right? I did feel like his Stuffmadehere's solution was, like, it felt very complex.
Because matching pieces share identical edges. Now, even for a small, simple puzzle like this, that's over 200 edge comparisons that need to be made. So the first step is just to look at the overall length of each spline and disregard any edges that were significantly longer or shorter.
I'm sure,
and that's typically
but I also feel like even just the way they took the pictures, right? Like, they didn't need the crazy lens that, like, frickin' made it look like everything was from infinitely far away. And I also, like, Shane's camera saw at such a precision, he was seeing the little hairs on the puzzle pieces. This is just a phone camera, right? I mean, I feel like they found a good way to probably eliminate a lot of the complexity.
The idea was to run a serpentine pattern over all the pieces.
Although I'm sure there's still tons of complexity,
and then isolate them against the background, then convert the edges of every piece into 4 splines. So if we wanted to find a match, say for this edge, we would just need to take that spline and then find the puzzle piece that had a corresponding edge spline that matched up perfectly, because matching pieces share identical edges. Now, even for a small, simple puzzle like this, that's over 200 edge comparisons that need to be made. So the first step is just to look at the overall length of each spline and disregard any edges that were significantly longer or shorter. And that typically reduces the solution space by about 50%. Then for the remaining candidates, we would overlay the splines and then quantify the mismatch by calculating the area between the 2 edge splines. So 2 pieces that were obviously not a fit would have a lot of overlapping area, whereas 2 pieces that were a perfect match, the overlap area would essentially be 0. From there, we looked at all the possible spline matchups and ranked pieces as potential matches with each other from least overlap area to most.
And this also, I feel like, seems like there's definitely still, like, crazy math that's gonna go on here, right? But this also seems like a way more direct approach than Shane's crazy, like, 128 variable dimension superplane, hyperplane, and cutting it into a million different categories, right? This seems like they've really honed in on finding a more human solution, right? Something practical.
Then Jigsaw would start with one of the 4 corner pieces and map out the potential solution space, which you could picture visually like this. So the correct solution is the only one that finds a good fit for all 12 pieces of the puzzle, but as you can see, there's lots of forks and dead ends. And that's because sometimes it was really obvious what the matching piece was, but sometimes there were 3 or 4 close contenders because the edges are so similar and our pictures weren't always perfect. So Jigsaw would always pick what seemed like the best match for a set of 2 pieces, but at some point the puzzle would only be halfway done and there would be no more good candidates to match the edges to continue solving the puzzle. And that's a dead giveaway. He chose the wrong piece somewhere previously up the chain. So he would work his way back to the closest fork and then choose the next best option. And he would keep doing this over and over until he found a path that finally connected all 12 pieces with essentially 0 spline mismatches at every connection. And then at that point, because he took pictures of all the pieces, he knows exactly where each of them is starting from over here, and he can simply assemble the puzzle using the precision he demonstrated back in steps 1 through 3. So it was working on a 12-piece puzzle, but now for the real challenge. Could we scale that up to a 1,000-piece all-white puzzle? Since our ultimate goal was to dominate the world's fastest human puzzle solver, we figured maxing out the number of pieces would give the advantage to the non-overwhelmable robot. So after a couple more long weeks filled with plenty of late nights working through all the challenges that come from scaling up a simple prototype 100 times over, we landed here. It's 3 a.m. After 3 years, we're at this moment about to fully solve it for the first time. What's our confidence level?
I'd say 100%.
Wow!
0. 0 in his heart. Anyone who does any sort of work like this knows that the first time it's not gonna work.
The code always works on the first try.
And so with
Cap.
that very heavy dose of sarcasm, Jigsaw got to work, starting first with taking all the pictures, and that took about 1.5 hours. Then after we had the pictures and we did the prep work on them I mentioned earlier, it was time for Jigsaw to actually try and solve the 1,000.
You know, what I do feel like they did, that he didn't do, that probably like, eliminated that issue of the, like, you need the fancy scope that shows it from infinitely far away, is I suspect he was talking about how, hold on, I need the drawing again. This is what I'll do. Because I'm a genius, I think. Okay, yeah. So Shane was talking about how, like, if you have a piece that looks like, yeah, you have a piece that looks like this, right? Wow, that is a really ugly looking puzzle piece, right? But if your camera looks at it straight on, it looks like this. But if your camera is, like, shifted slightly, then you, like, start seeing the little edges. And that messes it up, right? Because you're seeing this edge. You're seeing all the edges that are towards the camera. And then if your camera is, like, over here, then you see a different set of edges, right? And that, like, also messes up your picture. Because you see these edges, right? What I think they did is they probably just took a bunch of different pictures, right? From each side. And they probably just, like, set up an algorithm that, like, sort of averaged them, right? And that seems like a more practical solution to me than than your fancy camera lens set to take it so that there's no perspective in your picture. But I don't know. I don't know exactly how they did it, but it seems like they, like, this seems so much more human than
we did the prep work on them I mentioned earlier. It was time for Jigsaw to actually try and solve the 1,000 piece
also,
puzzle.
it's really cool
and
seeing
astoundingly, while running on just a simple laptop, the actual time to figure out the correct placement of all 1,000 pieces was less than a minute. And
Shane's program took like an hour and a half or something for, like, the 9-piece puzzle. I guess this is where he was like, I did it in Python. I'm sure C++ would have been faster. Probably. Mark Rober's team probably a little bit more specialized in their coding.
Placement of all 1,000 pieces was less than a minute. And I love how you can actually see him working his way around the puzzle from the top corner, solving and then going back each time he hits a dead end to try and find a different fork in the solution space until he finds the only combination that makes them all fit perfectly. So at this point, all that was left for Jigsaw to do was get...
I mean, isn't it computer vision, right? Like, the computer vision is the algorithm that's doing the edge detection, I would think, on some level, right? You need edge detection to know, like, where the puzzle piece is. It has to process the image. But I mean, I'm not a specialist in that, so maybe I'm just sort of speaking out of my butt.
Get to work placing the pieces since he now knew where every single one needed to go. And things were looking really good. And just as we made the mistake of having some kind of glimmer of hope, a single piece didn't quite snap into place. And then a bunch more followed right behind. And upon troubleshooting, what we discovered was there were a few very small sources of error that tended to compound on each other the more the puzzle was assembled. So for example, there's always a little slop between any 2 puzzle pieces, which adds up over a lot of pieces. Or another source of error is the whole puzzle itself shifting slightly when certain pieces were laid down. And this led us...
This is where I really liked Shane's idea that he actually didn't implement, of, like, you put a bunch of holes on the table and you have, like, a big vacuum under that pulls vacuum and sucks the pieces to the table and it holds them to the table. I think that was, like, a really good idea. I'm sort of sad that he didn't end up implementing it.
Just to realize Jigsaw was actually still missing one final important feature us impressive humans possess, because if you think about it, when we assemble a puzzle, we first just approximately place the piece where it needs to go, and then we rely on those highly sensitive nerves in our fingertips to form a feedback loop with the brain to make really tiny adjustments until we feel the piece fall into place. And then a double tap is the customary move to make it official. But since Jigsaw doesn't have nerves in his gripper, we approximated that with the Z-height encoder on a spring-loaded linear slider. And that encoder is so accurate, if you slice the human hair lengthwise into 50 pieces, Jigsaw could feel that tiny hair slice if it was resting on top of the table. So now if Jigsaw went to place it, feel that tiny hair
Guys, do you see his mouth?
Slice if it was resting on top of
he turns into the O mouth, like, surprise Pikachu.
The table. So now if Jigsaw went to place a piece and he could feel it hadn't quite snapped into place because it was resting too high, he would employ a wiggle routine where it would just barely translate the piece into various directions until he got the feedback from his finger
That's
that the
really
piece was
impressive,
fully
though.
set
This is
down,
maybe
at which point he would
overcomplicating
give
it
the
too. I
customary
don't know.
final tap like any puzzle solver worth his salt. And so with Jigsaw's new hardware and software upgrades, he was ready for one more final attempt. And I should mention, by the way, from a combined hardware-software perspective, this is by far the most challenging build ever on my channel, and that includes the auto bullseye dartboard and the automatic domino robot dominator. So if you really want to appreciate all the juicy details, including all of the source code, you can
Yes,
find a link
the
to the
hammer,
full
the
write-up in the
ultimate-
video description.
ultimate
You boys ready to
engineering
try
tool
this again
for
officially for the
percussive
48th
maintenance.
time?
Better work this time.
What's the confidence levels at?
100%.
Have you learned nothing, Ian? Hit the dang button. So Jigsaw got to work, and after
100%.
taking pictures of all the
Every
pieces, he once again actually solved the whole puzzle in a mere 55 seconds, which meant it was time to put them all together, and thanks to the new wiggle routine, you got this, Jigsaw. The first 20% was knocked out in less than an hour. Okay, I guess we can sit back down. And that meant while Jigsaw was doing all the hard work, I just get to kick back and relax in a state of zen, gazing at this polar gantry sand garden that you can build yourself. Because
Maybe
unlike the
Ash.
Crunch Labs build box, which is made for kids, we just launched Hackpack.
It's, you say that like it's very impressive, but it can't even, like, I can't even really squint one eye. It'll only detect if my eyes like fully closed. So I don't know. I'm sure they could pick up some, optimization from different hardware here and there, but
Which is kind of similar,
I'm sure
it's
they
just
ended
more
up
advanced
with
and
plenty
created
of things that worked
specifically
out.
for teenagers and adults. With Hackpack, you get a series of really fun programmable robots delivered right to your door, where we build it together and learn step by step the kinds of engineering skills that go into making the builds on my channel. They're all super fun and even useful, and they'll work right out of the box. No
Have you guys ever
programming
tempted
required.
to buy these adult toys? Not like not like adult toys, but like these basically they're just toys, but like as an adult you can still appreciate them. I didn't mean it like that, Rax.
Adult toys?
But since my goal is to get you to always level up your skills, with some simple
Yeah,
code
Mystery,
tweaks we
it-
walk you
like,
through, you can level up the functionality of
definitely
your robot or
a
get
lot
totally
more team
creative
effort
with some
here
hacks of
than-
your own. So if you want
than
to
Stuffmadehere.
enhance or even just take the first step of unlocking
It's very
the really
polished.
fun and rewarding hobby of making stuff, just go to crunchlabs.com or use the link in the video description where
exactly,
we're giving
Mystery.
away one free
Like,
box as an early
cars
subscriber
and
special.
machine
And back over at
tools
Jigsaw,
are like
things were
adult
looking
toys.
very promising for the world record attempt of an off-the-shelf puzzle completely solved and assembled by a robot with
Also, guys, I mean, when Stuff was doing it, his machine just, like, plopped them down wherever. This one is doing it, like, left to right, and I'm not sure if I like that better or worse. Like, this is very visually, like, there's something cathartic about watching it go left to right, but I thought it was really cool seeing, like, when Stuffmadehere's one did it, it was just... You just saw, like, random pieces all over the place, and then slowly but surely, the random pieces started materializing into, like, a full
with
puzzle.
no human intervention. Some pieces would go right in,
Uno.
Ash,
some
where do you get your
required a little
Arduino
bit of
stuff?
wiggle,
Oh, actually, yeah.
and some required a lot of wiggle. But in the end, let's go, Jigsaw!
Come on, last
Come on! Jigsaw always came through. Yes! Now feeling more confident in Jigsaw's abilities, it was time for him to meet the greatest Jigsaw puzzler the human.
Also, by the way, I mean, I just want to point out why one of the really big things I appreciate about Stuff is, like, Stuffmadehere's videos always show how much time he spent failing. Over and over and over again. This video made it look like a breeze. They're just like, oh yeah, I mean, we just, we slapped together a machine with a phone camera and it just bing bang boom puts the puzzle together. Ada fruit? I don't know. I was hoping earlier today to pick up some stuff like that to do some figure out some lab plans for the future to build some cool stuff. And I was hoping there'd be like a hobby shop or something that sold like, you know, circuit components nearby. And I could not find one nearby. The machine looked pre-built? Wait. Sorry, my YouTube thing... Freaking... The emoji thing is directly over the right side of the comment, so I can't always see the right side of the comment. 1 second. 1 second. Sorry, I messed up my OBS ever so temporarily. Oh, okay. The machine looked pre-built, like they used a plasma table or router. Huh.
Human race had to offer.
What? Are you done?
Who, fun fact, also happens to be a national Sudoku champion, Tammy McLeod.
I'm the human benchmark according to my child.
I first wanted her to face off against the best jigsaw puzzler I personally know, my dear friend Kristen Bell, aka Anna, or Veronica
How does he
Mars,
know
or
so many cool
Eleanor,
people?
or a bunch more. Kristen, ever since I told you I was making a puzzle robot, you've been talking so much trash.
A little bit of trash, yeah.
The puzzle robot isn't here today, so instead I have a friend I want you to challenge. This is Tammy. She holds the Guinness World Record for the fastest puzzle ever solved by a human being.
Hi, Kristen.
We kick things off with a simple 30-piece puzzle, and to be honest, 3, 2, 1, go. Kristen started off pretty strong.
So where's the elephant? Tammy, you don't talk while you're doing it?
I mean, I could trash talk, but
Do
I
it.
guess
You're
he's
gonna
famous
lose,
enough
Tammy,
that
and
he
then
just
you
has
hit me
these
back.
connections, but...
Wow,
Oh my God.
that was 1 minute and 5 seconds for a 30-piece puzzle.
I'm sweating so much.
And that was a pretty decisive win, but I wanted to see one more face-off, only this time with a 500-piece puzzle and a huge advantage in Kristen's favor. I think I'm gonna help you on this one.
Okay.
And with Kristen's renewed confidence, the clock started.
Her
And
moment of processing, she's like, yeah, I guess.
Tammy was so confident in this 2v1 matchup,
She's just doing flipping? Oh my God, that's crazy organized.
she saw no problem in helping our cause.
Where's that little?
his tail.
Thank you.
Right.
Thank you
Can
for
I
the
ask you a
throne.
sincere question?
Throne stuff.
Is this the robot?
Now, admittedly, I did have an ulterior motive for this matchup, and that was espionage. Tammy, I noticed you're using the box.
What?
Tammy, get real. You have to look at the picture.
It'll just distract me. I look at the pictures. I have good color acuity. I have very bad shape memory.
So if you, say, had to go against an all-white puzzle,
That would maybe my Achilles heel.
and this was a very useful bit of information, but she didn't stop there, because she also told me the 4 tips she tells amateur jigsaw puzzlers to help them solve puzzles faster. First off, dump out all the pieces and turn them over so you can see them all at the same time. For number 2, most people start with the edge pieces, and that's not a bad move, but it's not always the best. For example, if there's a puzzle that has something like a gold frame around the outside, you should set all the edge pieces aside and then leave them till the end, where there's a lot more information from the interior pieces to help with the border. For tip 3, look for groupings that catch your eye and organize them into piles. So for example, you could organize by colors, textures, or patterns. But either way, you're trying to reduce the search space into smaller chunks, because scanning and pattern matching are different parts of the brain, and this way you don't have to do them at the same time, which makes it easier. And finally, if you're down to a bunch of pieces that all look the same, like a blue sky, sort by shape based on how many ins and outs they have, and orient them all the same way. This will leave you with 6 total
It's so
piles and will
methodical.
make it much easier to find the final matches. And I needed to look no further than our current matchup. Oh no, I look away for 1 minute. Don't look at Tammy's, Kristen. Things are about to dire. To understand there must be some
Eyes.
validity to these 4
Her eyes
steps.
got
Not
so
seeing your
wide.
hands move or your eyes look at the board. I'm not trying to. I'm not trying.
34 minutes and 2 seconds, 500 pieces.
Congratulations.
Congratulations. Your next puzzle match will not be against mere humans. And indeed, after setting things up at Crunch Labs, we were ready to go. Tammy, I'd like to officially introduce you to Jigsaw. This is my upgrade from Kristen. And Jigsaw was in no mood for conversation as he got straight to work.
All right then.
As Tammy entered the matchup of
Jigsaw's
her
a
life with the weight
machine.
of all humanity
Hey,
resting
Arcanic, how are you? How are you doing? We're watching videos on puzzle-solving robots. We just finished watching, I mean, I guess maybe not just, but what we watched earlier was there's a YouTube creator called Stuffmadehere who built, like, his puzzle-making robot, and that was, like, a year ago. And now, just recently, like a week or 2 ago, Mark Rober released a video on a puzzle-solving robot. So we're comparing, right? And then, I mean, these content creators are so freaking smart. I mean, it's mind-blowing, like, the solutions they come up for these things. But yeah. Hope you're having a good one.
On her capable shoulders. What's your strategy here?
The only shape I can make use of is the edge.
Okay. How we doing, Jigsaw? Not really sure what I'm supposed to do now. But that's what I remembered. Jigsaw.
Like, do you think someone intentionally moved it? Someone, like, pushed a button to make it acknowledge him? Because he, like, asks it a question and then it, boop, just moves, doesn't even do anything.
I'm not sure what I'm supposed to do now. But that's what I remembered. I had a specialized skill set of my own. I might need to take measurements on your neck later. I'm making you something.
Why
That's
would
why
your
you
roommate
don't have
be
any
brain
pieces
dead?
placed yet on your teeth.
Wow, Tammy. You're familiar with the saying,
She's
measure
also, she's so sassy. Sorry, I was speaking when she was speaking.
I might need to take measurements on your neck later. I'm making you something.
That's why you don't have any pieces placed yet on your teeth.
Wow, Tammy. You're familiar with the saying, measure once, cut twice? No, that's not it. And as if on cue, my teammate wrapped up his measuring, there's a corner piece, and began cutting.
Did you have to make him so noisy?
3 pieces! 4 pieces! Tammy, ignore me. Saying 5 pieces!
It ain't over until it's over.
You're still winning, Tammy. Don't let it get to your head.
He's
And while I
clearly
was
trying
tempted
to
count
distract
all
me.
1,009 pieces. I decided to take up woodworking instead. Are you nervous, Tammy?
Even if I lost today, my family would still love me. Jigsaw, if he lost today, would you still love him?
No. My love is very conditional. Having properly reminded Jigsaw what was at stake, Jigsaw
If
has
you
now
fail, I
officially
don't love
taken
you
the lead.
anymore.
Jigsaw continued to make steady progress, while Tammy,
Where's that last edge?
oh, you need 1 edge piece, face the limits inherent in biology. I really want to actually help find this for you, that way I could say you needed my help. Without the precise search capabilities
I found it. I'm done with the edge.
of a smartphone to laptop nervous system. Click. Love that
Is
sound.
there any way I could get some water?
Jigsaw, do you need a water break?
The counter
You
shade.
notice we are missing a piece in the middle. That's on purpose. I was the ideas guy, and Jigsaw was the muscle. Jigsaw, that's your next piece right there, buddy. I'm a team player. The only thing is, he can be a bit of a control.
Okay, guys, do you think Jigsaw memorizes where the pieces are? And then, like, afterwards when he's like, oh, I need piece 835, he, like, goes to where he remembers seeing them? Because if that's the case, like, does that mean if after Jigsaw, like, scans all the pieces, if Mark just moves one, it just completely breaks Jigsaw?
Jigsaw, that's your next piece right there, buddy. I'm a
Or, like, Tammy shakes the table and they all shift just a little. It breaks him.
team player. The only thing is, he can be a bit of a control freak. So I opted to help Tammy instead. Tammy, do you need this piece? Do you need this piece? Do you need this piece? Do you need this? And so
Literally, me during my parents' road trips when we were kids. Are we there yet? Are we there yet? Are we there yet?
while Jigsaw continued to widen the gap, I made myself useful by woodworking, solitaring, finding Waldo,
I wonder how
Tammy
many
right
hours
here,
this was.
I'll look later.
and just generally reverting to the role of my youth as the annoying youngest sibling. I love doing puzzles. And after all that, Tammy had made a lot of progress. Tammy, I have good news and bad news. The bad news, there's only 8 pieces left, but not enough. The good news is, I made you a scarf. In fact, if you assume it takes 1 second per side to try all the remaining
She's so
combination of
cute.
pieces she had left, working 12 hours a day, including weekends, it would take her 1.5 months to finish. Which made this a good time to throw in the towel. Unless you're about to finish.
I think I'm good.
She should just
this
move
is a
the last
moment.
piece,
1,000
and then Jigsaw will never win.
pieces in 4 hours. Okay, Tammy, you represented us humans well, but alas, it's time we welcome our benevolent robot overlords.
It's an honor to lose to him.
The style
beautiful.
points to just drop it in the spot.
Good work, Jigsaw. At ease. So while Jigsaw took his victory lap, I put the final touches on the trophy I'd carved her. You are the best the human race has to offer, and you did a great job. Just, you know, not that great.
Jam the rails.
If you're a teenager or
break the
adult and
servos.
you've always wanted to make and build cool stuff, but just haven't figured out that first step, this is it. It's called the Crunch Labs Hack Pack. And it's basically a series of really fun programmable robots that get delivered right to your door, where we build it together and learn step by step the kinds of engineering skills
How many
I'm going
takes
to
it
make
took,
builds
Mystery?
on my YouTube channel. And they all work with no programming required. But since my goal is to take you from wherever you're at and
Yeah, I
level
mean,
you up,
I
you
don't
can
know if it's a
easily hack
question
the
of takes,
microcontroller brains of any
'cause
of these
I'm
robots
sure
in a bunch of ways. ways to
time they were at
completely
this
level
point,
up the
it was
functionality. There's also a community
like
where you can share your
95%
builds or
reliable.
post
I'm sure
questions, as well as an AI
by the
chatbot
time
named Mark
they were
Robot that will check your
filming
code
this,
for you and help you implement
the
your
robot
most
was very
creative
reliable.
ideas. On top of all that, each box has a chance to contain a platinum diploma. And if your box has it, congratulations, because college is now free
The
for
Visa
you
shirt?
or a loved one you want to transfer it to. Plus, you get to come out here and brainstorm one of your own
how many
ideas
takes it
with
took
me
to
and my
cut
team
these?
for a day.
I
So
don't
if you
know.
want to enhance or even just take the first step of unlocking the really fun and rewarding hobby of making stuff, just go to crunchlabs.com or use the link in the video description. We're to say thank you. We're giving away that free box as an early subscriber special.
You want it, Ash? You want like this like Crunchwrap? Not Crunchwrap. Maybe I'm just hungry and it's a like Freudian slip of me wanting Taco Bell. This Crunch Labs like grown-up toy box. Oh God. maybe you can come over and we can build one together. Build one together.
Thanks for watching.
But, like, I feel like just this video does not... Like, you remember
Can
how
I have
much
your crunch
struggle...
wrap winking face?
How much struggle we watched Shane go through, and we didn't see any of that here. I feel like basically none, right? But I think he said this was like a 3-year project. Condensed down into 20 minutes. But, yeah, I mean... It's certainly crazy, like what these people can do. Because I could never. The intern struggle. I mean, I guess he probably does have interns, right? Maybe that's what like the Crunch Labs like summer camp kids do is they slave away as intern labor. Let's very quickly look at the Michael from Vsauce short, since it's a short, and see what Arcanic is talking about. But what I do want to show, since we were talking about it earlier, is I want to show Stuffmadehere's shop tour, where he shows off all his fancy tools and builds something different with each of them. Okay, which one? Is it this one?
I built a solenoid engine. Unlike most motors out there that hide how they work.
Wait. Do
this beauty?
Are there actually Legos that are shaped like this now?
Here's all. A solenoid is a kind of electromagnet. When electricity flows through this coil, a magnetic field pulls the magnet-topped piston inside.
That's not what I was reading.
But when the piston reaches the top, a cam on the axle it's turning cuts off the flow of electricity, and the flywheel's momentum pulls the piston back down. But once down, the cam disengages, electrical flow resumes, and the piston goes up again. You can see how it turns electrical energy into rotational energy. To make this happen, my team and I got to design a bunch of
what I was talking about was like the fancy looking Lego gears that are like
compatible parts that I had been wanting for a long time. Special cams, pistons,
ADHD
arms, wires, a heavy
brain.
brass flywheel, and of course, the solenoids themselves. We even made...
See these ones. There's like oval shaped gears. Does Lego make these or are those custom? And then there's like seashell shaped gears.
elliptical gears, Nautilus gears, and a Geneva mechanism. If you'd like to build one yourself and add
a Geneva mechanism,
these parts to your
necessary for when we break the Geneva Conventions.
arsenal? Too bad, so sad. Psych! You can buy one. ABS plastic?
$200.
Ooh, and look at those
Holy
colors.
cow.
The first 500 people to use code I love you, Michael, will get 10% off.
These remind me of Cheez-Its. Forbidden snacks.
I built a solenoid engine. Unlike most motors out there that hide how they work, this beauty bears all. A solenoid is a kind of electromagnet. When electricity flows through this coil, a magnetic field pulls the magnet-topped piston inside up. But when the piston reaches the top, a cam on the axle it's turning cuts off the flow of electricity.
Okay, this is me being classic ego brain, saying I could do this.
And the flywheel's momentum pulls the piston back down. But once down, the cam disengages, electrical flow resumes, and the piston goes up again. You can see how it turns electrical energy into rotational energy.
Yeah, Ash, I remember the Lego Mindstorms.
To make this happen, my team and I got to design a bunch of custom...
Wait, he has a team? He has an engineering
cross-axle
team?
compatible parts that I had been wanting for a long time. Special cams, pistons, arms, wires, a heavy brass flywheel, and of course, the solenoids themselves. We even made elliptical gears, Nautilus gears, and a Geneva.
It's also, do you guys notice how it's like wobbling? Like the linkages on the Legos are wobbling. Get some BMW engineers in here and cover that thing.
The mechanism. If you'd like to build one yourself and add these parts to your arsenal, too bad, so sad. Psych! You can buy one. ABS plastic? Ooh, and look at those colors. The first 500 people to use code I love you, Michael, will get 10% off.
I love you, Michael. It's cool. It's definitely cool. And it maybe is cooler in the fact that I can definitely... it's something that seems like within reach for me. As opposed to like the Stuffmadehere projects, right? But like... Look at this shit. Look at the shit this guy builds. Hold on. Where's the one we want? We want... the one where he shows off all his fancy shot machines. Here we go.
So you may have noticed.
Have a good night, Ash. I hope you had a good time in stream, and I hope you have sweet dreams. Sweet dreams.
I have a lot of tools. In fact, my wife tells me, you have a problem. And everyone else tells me they want a shop tour. But I just can't show you all my tools without some results. So here's what we're gonna do. I'm gonna design and fabricate a catapult with every machine in my shop. That's 9 catapults, and they're all gonna be totally different. And this will let me show you the machines and how they work, but it'll also give us some really fun results.
Oh, whoops.
I also see some very exciting ways to prank my wife.
What's in the box?
I have all these tools so I can make whatever pops into my head as quickly as possible. They're basically the conduit from my brain to the physical world, and it's awesome. Each of the catapults that I'm gonna make corresponds to a different part of the shop. I have tools for working with metals and plastics, additively and subtractively, and a whole lot of other stuff. This should be cool because it'll show just how many ways you can solve a problem.
Thinking this through, I'm gonna have to stretch the definition of the catapult really far. This is definitely a catapult, right? So here's my rules. It shoots 1/2-inch steel bearings. This is the premier size to take an eye out. All of the important parts need to be made on the machine. So if I was making a 3D printed catapult, I couldn't just 3D print the trigger for a potato cannon. I'm gonna be trying to keep the danger level to about a 3 out of 10. We'll see how that goes.
Oh my god.
I had try not to get too carried away, but I've already broken that rule, so it's gone.
I really should stop saying catapult, but I've said it too many times. So they're catapults. We're gonna start simple with some of the more basic tools. I'm limiting myself to the bandsaw, the drill press, and the belt sander.
For all of these designs, I'm using a really important tool called computer-aided design, although most people just call it CAD.
I'm using Autodesk Inventor to design everything in the computer
Toys
before I
enjoyed
build
by all
anything.
ages. Fair?
Doing this means that everything usually fits together, and
I
it
don't
also
know,
lets me
maybe-
do things like
maybe some of these are not fit for children.
calculating the strength. I came up with this kind of wacky handheld catapult, and I'm using the 3D model to make paper templates so that I can cut everything out accurately. This is a really powerful.
I just want you to know that CAD is never going away, Arcanic. Your second year of college, CAD is not going away. The software tools that you need for engineering are not going away. MATLAB's not going away. Just remember that.
Technique. You can make almost anything this way, it just takes a while. I'm using a little portable bandsaw on a stand that I made, and this thing is incredible. I use this on literally every project. The drill press and belt sander are cheap imports from Harbor Freight. I've had them for over a decade, and they just won't die. I kind of wish they would so I could get a better one.
You can do an incredible amount of things with these machines. They are definitely the most bang for buck way to get into making these kinds of things that I know.
I invested in a high quality 8-inch vise early on, and I have zero regrets. This thing is amazing. I'm also using it to do some low-end blacksmithing. A little glue and a couple screws, and we've got a catapult. It looks like I just have one of those little white Looney Tunes surrender flags on it, doesn't it? All right, let's try it out.
Cock it like this. Ball goes here. I don't even know how to aim this thing.
I feel like... Oh, it doesn't go as fast as I thought.
Because I love everything that I make, I asked my wife to give an impartial score. Really, a 4?
If this was a competition for a food fight tool,
focus
then it
your
would be
camera,
higher.
Shane.
You're lucky it wasn't loaded. Breaking glass isn't the most scientific test, but it's the funnest test.
This catapult is just impossible to aim. Well, that was
Right?
anticlimactic.
Rip.
Let's make the
Not
next
enough
catapult.
energy.
I am so jealous of kids these days growing up with their fancy 3D printers. When I was a kid, all I had was a corded drill and a rusty chisel, and I liked it. Anyway, I'm gonna make a catapult with my fancy 3D printers. I came up with a design that's fully 3D printed, including the spring. Plastic doesn't really want to be a powerful spring, so I have 18 kind of weak plastic springs working together to make one mighty spring.
This is one of the 3D printers I'm going to be using. It's called a Form 3. It's a resin printer made by Formlabs. And as a fun little fact, I was actually
So wait. In terms of what he said the goal was, he said the goal was to make, like, to be able to make the entire catapult out of the same machine or same set of machines. So if this is his 3D printed catapult, he can't 3D print a spring, or he can't use a spring that's not 3D printed.
responsible for developing this machine. That's what I was doing before I started making YouTube videos.
This machine has a tank full of liquid plastic, which it shines a very tiny laser spot at, and wherever the light touches the plastic, it triggers a
This is
chemical
so
reaction
cool.
that turns it into a solid. The machine will steer the laser around to cure a very thin layer, and then it'll move that layer up and then cure another very thin layer on top of the previous layer. If you repeat that a bunch of times, eventually you get a solid thing. The parts come out sticky, so you wash them off in a bath of basically
I think the spring thing was he? I can't remember. He does have essentially a 3D printed spring in this, but it's not like a spring like you would think of. It's just another means of storing the potential
rubbing
energy.
alcohol. These weird structures that the parts are on are automatically generated supports. This is actually an algorithm that I spent a lot of time on. They're super optimized, so they just break off and you have a nice part.
If I could only have one tool in the shop, this machine would probably be it. So I don't think I've shown this in any videos. This is an SLS machine. It's called a Fuse 1. It's also made by Formlabs. It prints things out of nylon powder, and the parts are just fantastic. I said this is an SLS
crazy.
machine,
The
but I
tech
think
we
the
have
more
is
correct
crazy,
technical
guys.
term for this is an
Also, rest in peace, ad viewers. I think there are ads going on. Maybe not. I don't know. Arcanic, do you suffer from ads? If not, then I don't think anyone does, but I'm not sure. Not sure. Because I know it seems like a lot of people from other countries don't seem to be ad sufferers. But yeah, I don't know. I was just thinking that if he is hearing ads. Okay. I was just thinking that if he could hear me, then he would respond, right? Yeah. We'll chill for a second while ads are playing. But like, tools these days are so fancy, pantsy, right? And he's got, okay, ad done? Ad done already? Wow.
absolute fantastic. I said this was an SLS machine, but I think the more correct technical term for this is an absolute unit.
It works by spreading out a very thin layer of nylon powder, and then it melts together the areas that it wants to be solid using a laser. And just like the other machine, if you stack a bunch of these layers on top of each other,
Who thinks of
eventually
this
you get a
stuff?
solid object. The parts come out surrounded in powder, and you sift through it like an archaeologist. This
That does
machine
seem
collects
super
all the
fun, though.
unused powder and then recycles it back into the machine so you don't waste it.
If something I want to make can be done on a 3D printer, that's what I'm going to do. They take the least amount of work by far, and they can also do the widest variety of shapes of any tool in my shop. The reasons that I won't use a 3D printer is that I need something big, very accurate, or very strong. I also want to mention that I did not buy this. It was given to me, and that's actually true of almost all the big expensive tools in my shop.
This has been one of the best things about
How
having
famous?
a YouTube channel. And it's
How
great
famous do
because
you have to
you
be to
win,
get all
I
these
win, and the toolmaker
free
wins
toys?
when something awesome gets made.
And I'm so grateful to be in this position.
So this is like the quote unquote spring mechanic. I think is this piece.
There is just way too much to show here. If you want more details,
in that, you know, you're just loading the kinetic energy into each of those little flaps.
there is just way too much to show here. If you want more
Potential
details,
energy.
keep an eye on my second channel.
So this one's pretty similar to the last one, except for that it's totally different. You cock it like this, put it in the ball, and you're ready to fire. These things are just impossible to aim. That was kind of weak. IV4. This is better than a 4. 18 leaf springs. Or 1, 2, 3. Yeah, 18 leaf springs.
If one snaps off, won't it affect the whole assembly? I don't know if I think that's true. Depending on the design.
I have to know what a leaf spring is to be impressed by that.
It's very
Will it break
common
the glass?
mystery. Is it common
Yeah, I
enough that
didn't
in the
think
future
so.
I can have these toys?
All right, next up, we're gonna be looking at the CNC router.
It's a Tormach 24R.
It's basically a wood router attached to a robot that can move it around to cut out whatever shape you want. It's really good at making big things out of sheets. It cuts up to 2x4 feet. I use it to make all kinds of more precise wood stuff, and especially explosive bats. I think a trebuchet would be perfect for this router. I was chatting with patrons on my Discord, and someone brought up the really good idea of a floating arm trebuchet, so that's what we're gonna do. I'm holding the wood in place with plastic nails so that I don't break the bit when I hit one. I love using the router because it's really easy. You put your wood in, it cuts the parts out, and that's pretty much it. And those plastic nails just shear in half with a hammer tap. This whole thing goes together kind of like Lincoln Logs.
The way I designed this is just a little bit too narrow. Here we go.
I want free tools. Oh my god.
That is way more powerful. Are you just messing with me now? Let's just fire it with 10 pounds.
His
Ugh.
wife's just giving
Hopefully it doesn't
floors
break.
everywhere. Oh my god.
2, 1.
I'm surprised also, like, he doesn't have any protective gear on. Like, he
2.
didn't put up a shield between him and the thing. When this looks really uncontrolled.
1.
Oh my god, it broke.
Snap the arm in half.
That's why he should have had the
We
protection
won't
on.
get to find out if it would have broken the glass, but we all know it would have. Milling machines take a lot of work to use, but they're probably the most satisfying tool in my shop. I've really been looking forward to designing a catapult for these machines.
So one thing led to another, and I accidentally made something kind of insane. This is a centrifugal catapult that fires 1/2-inch steel ball bearings.
How do
full
people
auto.
think of this
This
shit?
is way overkill for demoing my mills, but I just couldn't help myself. It's so cool. So I'm gonna build it and show how the mills work, but there's probably gonna be an entire video just about the awesome things that you can do with this kind of machine.
The general idea is that you have a spinning arm that flings the balls.
By the way, I think there was some company is doing this for literal, like, space launches. Their plan for, like, launching thing into space is to have a big, like, big ol' spinner that just spins it up really fast and then whoop, shoots it off into the atmosphere.
Before we can machine anything, we have to cut our stock out.
The little bandsaw I showed
Yeah.
earlier is a total workhorse, but when you want to cut a slice off
Spin launch? Yeah, that sounds right. Also, hi compiler addict. We're watching Stuffmadehere's engineering videos.
something like this, it just isn't gonna
Hope
happen.
you're
So let's talk
Here
about
for
my
a good
horizontal
time.
bandsaw. It's a Grizzly G0613, and I love it. This thing is perfect when I have thick stuff,
I hope you're
long
enjoying
stuff,
yourself.
and when I need an accurate square or angled cut. This design is awesome because the entire vise rotates, and you can cut really accurate miters.
Guys, I will say, bandsaws are super, super horrifying to me. Just the idea that that thing cuts so quickly that you could lose your finger or your arm before you even felt it. That horrifying.
This is my first CNC machine. I actually made it in an apartment years ago, and
built
it
his
doesn't get
own.
much use these days because I have bigger and better machines.
Which is kinda
but
crazy.
Building this, I learned
guess
so
that's what
much about
happens when you're a
CNC.
genius.
I really recommend it. It is a fantastic baptism by fire. Computer-controlled CNC machines are amazing, but human-controlled manual mills are also amazing. This is my Precision Matthews 935. It's called...
Wait, did you say perfumes? What perfumes I used? That's like a weird... Am I misunderstanding? Are we talking about the same sort of perfumes? I mean, I'm... Like, you want to know what I was trying to make myself smell like? I don't know if I want to share that information with you.
Called a knee mill because of the configuration of all the pieces. It's kind of a standard layout. Machines like this are great because you can just throw stuff in them and start cutting. You don't have to go up to a computer and program the moves that it's going to do. It's super fast for a certain type of work that I do all the time.
Yeah.
It has knobs that you turn to move the thing you want to cut in 3 dimensions. And you pretty much just force the cutter into the metal and it cuts through it like butter. Did you know you can cut metal with a sharp knife? That's exactly what these machines are doing. They're spinning a round knife that just cuts through the metal. One of the most important things for milling machines is getting the speed and depth that the knives are cutting correct. People call these feeds and speeds. Whenever I show people the mill, they think that the part is going to be really hot, but it's not. Most of the...
Excuse me? Every time I've used...
The heat goes into these shavings, which are called chips, but they're not edible. There are tons of different tools and cutters to do different things in the mill, but I'm not going to get into those.
I'm also surprised I didn't see any like cutting oil on it.
I'm using the mill to make a bunch of the simpler parts, and this part, which you would normally make on a lathe.
I have 2 lathes, but according to my rules, I can't use them.
But I can use my mill as a lathe, which is a nice trick to know. Sometimes can get you out of a jam.
When I need metal parts for a project, which is like every project ever, I'm using this machine. It's a Tormach 1100 MX. It's a CNC mill, so it's just like the manual mill, except for there's a computer turning the knobs instead of me. Computers are fast and precise, so they can do stuff that I just can't do with my hands.
The liquid that it's spraying is called coolant. This lubricates the tool and keeps metal from sticking to it, and is really important for washing chips away so they don't build up and break your tool. It holds 10 tools that it switches between automatically, which is amazing because I can just put metal in it and it'll make the part for me while I do other stuff.
Arcana Key, I think back in the day he had a shop in his garage, but now he I think he rents out like a warehouse and has a shop in it. But it's a personal shop, right?
It also has this rotating axis that really reminds me of cooking something on a spit. It'll spin your part as it cuts, and it'll allow you to do all kinds of fancy things. You can get machines that have a rotary axis like this stacked on top of another rotary axis. It sounds kind of crazy, but you can do some incredible things with that setup.
I don't know if you're out there, Haas, but if you can hear me, I'd love to talk about a UMC 500. I can at least dream, right?
This thing is so over-engineered. I think in French they call this a resistance piece. Hold on, why is there a 3D printed part here? I mean, if you're gonna cheat, you might as well commit, right?
Cheater!
You spin the launcher mechanism with this crank and drop a ball in, and it should launch it.
Scarily fast. Again, I don't know why he doesn't have more protective...
It's not at all where I was expecting it to fire.
...things set up.
This is like my 100th try. Finally!
Needs more
More chooch means more power. And I totally agree with that score, although it's not really a score.
But it will be fixed. In a future video, I'm going to...
Powered by the drill.
Attach a high power motor to this and do some really cool things.
Menacing.
The other thing that it really needs is a timing mechanism so the balls go in at the right point of the rotation. Right now they go in at a random time and shoot out at a random point. We need them to always come out of the end of the tube at the same time so that they fly consistently. I'm not even gonna try to hit the glass. I could barely hit the foam.
Metal joining and cutting is a really important part of my shop. It allows me to make big, strong things really fast.
I'm going to weld up a steel replica of Da Vinci's catapult design. Before we can get to welding, I have to cut out a lot of thick steel, and we are going to use a tool that would have absolutely blown Da Vinci's mind.
Is it plasma cutter?
This is plasma cutting. It is raw power cutting through steel like butter. The way they do this is super cool.
It's
Plasma
so
cutters use electricity to make a super
pretty.
hot stream of ionized gas, which is called a plasma. Plasma conducts electricity, which allows an arc to form between the torch and the metal that you want to cut. The energy from the arc melts the metal, and the focused blast of ionized gas shoots
It's
the
so
molten
pretty,
metal away.
guys.
Add in some computer control, and you can cut
Why
out
are the
whatever shape you
destructive
want.
things so pretty?
This is a Tormach 1300 PL. It cuts up to 4 foot by 4 foot, and I cannot overstate how superior this is to cutting metal with a grinder or any other way. So this is the torch, and this is what does the cutting. You can actually move this around by hand, but here I have it mounted to this gantry, which moves it around and cuts out whatever
Moving
shape
it by
you want.
hand sounds
The whole
really
thing
scary.
is powered by a Hypertherm PowerMax power supply. I designed and built a plasma cutter before this one, but it isn't with us anymore. It's watching over the new machine from Plasma Cutter Heaven.
You right, Max?
And now
you
the
right?
fun part. I'm welding everything with a Vulcan Pro TIG 200 from Harbor Freight. It is surprisingly good, but you can't get it. As far as I can tell, Harbor Freight got sued so hard by Lincoln Electric that they just deleted the thing from the internet. It's a TIG machine, which stands for tungsten inert gas, which basically describes how the machine works. This pointy rod is the tungsten. It's charged with electricity, which makes an arc between it and the material you want to weld. This delivers so much energy that it melts the metal
Oh, it's
almost
so bright.
instantly. Although most metals have this annoying problem, when you get them very hot, they rust super fast. To avoid this, the machine flows a bubble of inert gas around the weld. In my case, it's argon. Argon is a noble gas, which means aside from its aristocratic lineage, does not want to react with anything. Unlike oxygen, which will react with pretty much anything that moves. Since argon won't react with stuff, you don't get oxidation. TIG doesn't really fume or smoke, which is great for the basement. When you're welding parts, the heating and cooling tends to distort them. So my welding table has a very thick top, which you can clamp the parts to, and this helps minimize the warping. All these holes, which make it look like a precision block of Swiss cheese, are made to accept drop-in clamps and other fixtures, which makes setup super fast and easy. If you're wondering, my welding table is called a Rhino cart. To make the catapult spring, I'm using...
Also, he's so good at so many things. Welding is really hard, is my understanding. I'm like, I don't know how he can do he can do all the engineering stuff. He can do all the machine shop work. He can weld. He has money, clearly. He can do all... why are people so crazy? I'll add the flashbang emote to my list of things to add. I think I added a pretty good amount recently, though.
Using this cool tool called a ring roller, and it's used for rolling rings.
I think that's as much as I'm gonna be able to do.
Oh my god.
If you put your hand in front of this and it went off, I bet it would break your fingers.
Now he has a tiny little plastic shield. Tiny little yeah, that's gonna save you from this catastrophic amount of energy stored in that bent metal.
Oh, gosh.
Are you guys enjoying the voices? Quality emote. Quality emote. Sorry.
Yeah, that's what I'm saying. Yeah, that's what I'm saying. That Da Vinci was one smart guy.
It's finally
With
not
a
a
few tweaks,
4.
this thing could be really powerful.
We all know what's going to happen with the glass, but come on.
I'm
I know
surprised
the
he
Da
didn't
Vinci
use
catapult is
tempered
fast,
glass.
but I want to know how fast. And I have the perfect tool for the job. So there's 8 of these cameras hanging from the ceiling throughout my shop, and these are motion tracking cameras. They're made by a company called OptiTrack, and you've probably seen these used in video games or movies. You see people wearing silly suits with white dots all over it. That's for these cameras. So the way that these work is they flash a really bright light that we can't see. It's invisible to humans, but the cameras can see it. And then anything that's reflective to that light bounces it back to the camera. This allows the camera to very reliably see the things you want to track. If you have multiple cameras, you can triangulate where that thing is in space. This is the same thing that your eyes do to figure out how far away stuff is. These things are super fast, super accurate,
Not
and the
OSHA
next
approved.
project
I
I'm
mean,
working on uses the
He's
heck
oddly
out of
safe
them.
in his lab.
I think it's
normally,
very
feel
fitting that you calibrate the tracking system by basically waving a magic wand. All right, the system is up and tracking a ball as I move it around on the table, and here we go.
Oh.
All right, this is pretty cool. This is the path that the ball took. The catapult zinged it up, it bounced off the foam, went into the ceiling, and then came out over here and fell to the ground. We hit about 38 miles per hour. It traversed my workbench in 150 milliseconds. That's how long a blink takes.
Yeah, I mean, this is like, why does he not have like some sort of like plastic shield or something? Some wall. Acrylic.
Machining is awesome, although starting with a block of material and removing everything that isn't your part is pretty slow and expensive. This is why I love plasma cut and folded sheet metal. You're only using the material that you need to make the part, and it's really fast and easy to make
Also,
big,
every time I
strong
see that
things.
machine, I
For
have
example,
the
an all-metal crossbow.
intrusive thought
This
of putting
crossbow
my
has been
finger in
designed
it.
to be folded out of thin sheet metal, kind of like origami. My CAD software can flatten it out into a pattern that I cut on the plasma cutter. This is basically the same as the Da Vinci catapult. When you cut thin sheet metal, a bit of the molten metal tends to stick to the bottom of the parts. I'm grinding it off at my downdraft. There's a powerful metal dust collector attached to it. This sucks all the metal particles away so they don't go into my lungs. I find it hard to spend toolbucks on safety stuff, but it is important. And it turns out my wife agrees. Finding a way to classify a tool as safety critical is the best way to sneak it by my wife.
Isn't that amazing? Just look at the hot dog.
Why don't you just not put your hand in the table saw?
While we're on the topic of safety, let me show you what I do for first aid.
Just don't
If you're
cut
gonna
off
have
your
big
hand.
tools, you have to be prepared for some big injuries. Tourniquet, just in case. This probably only applies to my shop, but if I have a chest wound, this will seal it. If I'm having a really bad day, it'll also seal the exit wound. We've got a skin stapler, which I hope my wife will never have to use on me, but it is pretty easy to catch your scalp on the stuff, yeah. This is what I use whenever my wife talks about one of my projects. This is super glue for closing up wounds, way better than bandages. This is actually made for animals, not humans, but I think it's basically the same stuff and it's a lot cheaper.
God.
Don't quote me on that, I'm not a doctor. Get the human stuff. The vet stuff is a bad idea, I'm an idiot.
Guys, he has probably hundreds of thousands of dollars in fancy tools, but he does not want to pay for the human super glue. No, too expensive. Get the animal super glue.
And I'm gonna be getting the human stuff probably. Bending
Not worth
sheet
the
metal
money.
accurately is really hard to do, which is why I have such a ridiculous bender. The technical term for this is a brake, and it's made by Grizzly. It'll do 16 gauge steel up to 50 inches wide, and this thing is phenomenal.
cows?
The amount of pain I went through before I got this thing is just off the charts.
Getting the bender is most of the work. Once you have it, it's pretty simple to use. You take whatever it is you want to bend and clamp it in the brake, and then pull this pivoting part up to whatever bend angle you want. You can also take these fingers out to make clearance for bends that you couldn't make otherwise. And that's it. That's my first secret to sheet metal success. I normally wouldn't give you the second secret until you recruit at least 3 people to the program, but I'm feeling generous. The secret is spot welders.
I think spot welders are just completely underrated. They are super useful, they're affordable.
Yes, exactly,
But I don't see
Arcane.
anyone using them. I just don't understand it. So let me show you.
You take 2 pieces of metal, clamp them in the spot welder, press the trigger, and you're done.
Really high heat, a bit of pressure, and 2 become 1, just like marriage.
Me and your mom last night, really high heat, more than a little pressure. And 2 become 1.
This will join all the pieces of the crossbow together super fast. I just love that even the string is sheet metal.
This one, you have to cock it with a glove on.
Oh my god,
You
that's
never want to get
terrifying.
your fingers in front of it.
It's pretty cool though.
It seems to have a lot less power than I calculated.
Look at how floppy the
5?
The thing
Can't
is-
believe you give that a 5.
As I said, for style.
It has 18 stacks.
It didn't imply that, Rex. It did not imply I was inside her. She could have been inside me. Yeah. 44% of marriage end in divorce in America. I don't know if I think that's true. That sounds high. I think it's probably like 20%. I don't know. I don't know if it's But I would guesstimate like 20%, which is already pretty high.
Back to leaf springs, my wife isn't impressed with, I'm sure. These ones are all touching each other, so they all have to rub to fire, and you lose a lot of energy, I think. I think it shows what you can do with sheet metal pretty well, though.
Racks.
It's only cool if you can break your house windows with it. That's too bad. I thought this one was cool. This next catapult is designed for laser cutting. Laser cutting.
Damn it, Arcanic. They either end in divorce or death, so clearly marriage is a bad idea.
Is a really fast, really useful prototyping tool. Before 3D printers, laser cutters were the king. My goal for this one is to make a wrist-mounted catapult.
So this fancy glass box, this is my laser cutter.
It reminds me of... Did you guys ever play with like the kids' toys of like they were like Spider-Man web shooters? They had this exact same firing mechanism where it was a little tab you pressed with your fingers and it shot the like crazy string stuff out. The silly string. Compiler addict. 100% mortality rate is also air, sun, you know, heart beating.
So this fancy glass box, this is my laser cutter. It's a Glowforge Pro. It cuts soft materials like wood and plastic with a beam of focused light.
The focused light is delivered by a CO2 laser. This is basically a glass tube filled with CO2 with electrical connections on either end. When electricity is applied, it causes some of the CO2 to emit light, kind of like a tiny light bulb. But what's special about this glass tube is that it has mirrors on either end. Some of this light will go towards the mirrors and start bouncing back and forth between them. And sometimes something interesting happens when the light goes by another CO2 molecule. The CO2 molecule will emit more light, which will be going in the same direction as the light that's already bouncing back and forth between the mirrors. This is called stimulated emission, and it's basically what the word laser stands for. So you get this enormous buildup of light bouncing back and forth between these mirrors. If you were to figuratively poke a little hole in one of the mirrors, some of this light will come through, and it will be an intense beam of light all going in the same direction, which doesn't really happen in nature, which is why lasers are so special. So whenever you point this laser at something, it just goes, "What the heck?" and disappears in a puff of smoke wherever the laser's touching it. You really don't want to breathe this smoke, so it gets sucked up into this filter. The laser's moved around on a gantry so that it can cut anywhere on a sheet. Laser cutters are great because they're really easy to design for, and cutting stuff out is fast and takes almost no work. You just load a 2D drawing of what you want to cut in the software and hit cut. That's it.
If you're in the market for one of these, there's a link in the description that'll get you $500 off. All right, who needs a taser when you can have a wrist rocket like this? All right, ready?
It's so underwhelming.
I really like how the low profile articulating pivot came out.
I think with a couple tweaks, it could be quite a lot more powerful. Think I look like Spider-Man?
She drew it so well.
Yep.
It does look like Spider-Man's web shooter a little bit, especially the way you fire it.
The glass is a lost cause. I accidentally kind of broke it, so it can't even hit the glass from 1 foot away now.
Rip.
Now for the project that's a real conundrum. How the heck am I going to make a catapult on the lathe? You typically only make round parts on a lathe, but I can't think of any examples of...
Wait, was that a threaded part? Or is it does it just look threaded because of the way it's spinning? Do people make threads on the lathe? Mystery? That sounds tremendously difficult.
Typically only make round parts on a lathe.
Probably not.
But I can't think of any examples of catapults that are made out of round parts. Well, lathe.
I mean, but they make the threads on the lathe? Mystery? Like, don't you have to be super, super controlled with the speed then? I mean, I guess if you CNC it,
but I can't think of any examples of catapults that are made out of round parts. Well, if you use my definition of catapult, I can think of one.
Unfortunately, using explosives are against my rules, so we're gonna have to do something a little bit different. Everything is basically round, and air pressure counts. It's basically a spring, so I have an idea.
I'm gonna build a launcher that you pump up and then release the pressure with a valve to shoot the ball.
I have two lathes.
Me of like a
this is my mini lathe, which I had in my apartment,
launcher.
and it is absolutely beaten to death. This is the big brother to my mini lathe. It's a Precision Matthews 1440 GT. This thing is just an absolute joy to use.
The lathes work by holding whatever it is you want to cut in some kind of chuck. As the chuck spins, you stick various tools into the part to cut material off. And just like the mill, it cuts into the metal like butter. There's a ton of different tools that you can use in the lathe, but the thing that they pretty much...
Hi, Verenius. How we doing? We're watching Stuffmadehere give us a shop tour building a bunch of catapults.
all have in common is that they make
Steel
round
potato
parts.
cannon?
I have an issue with the trigger valve for this launcher. Although it's possible, these parts are very difficult to make on a traditional lathe setup.
Did you know a lathe is just a mill on its side with some missing parts? We can add those parts back.
He's cheating.
Now, we have a mill.
Pretty cool.
You can do milling with this, but you should not put it into a quick change tool post. It's not stiff, and you can potentially...
This looks like, what this looks like is it looks like, you know, those pictures of like an extension cable in an extension cable in an extension cable, because you've got like one connection and then another connection and then another connection and then finally the clamp.
damage stuff. Be smart. Don't do what I did.
I was able to get this pretty simple. The hardest parts to make were the check valves for the pump. I designed everything to go up to at least 1,000 PSI, but I screwed up the pump and I'm way under that.
You pump this one up a bunch of times.
That's pretty cool.
Can it break the glass? That's the question.
No.
No? No?
Pretty cool stuff.
No?
It's so comical, the little thing just popping out.
Yeah. Won't even break the glass.
You showed me.
I showed you, yeah.
Wait, did it
Won't
break?
even break the glass.
Did it break? Or did it just knock it down? Oh, I guess it did break it.
Yeah. Won't.
He really should have shot for the stars and used tempered glass, and then it'd be like really fancy looking seeing it shatter.
Won't even break the glass.
You showed me.
I showed you, yeah. Not a great indoor toy. 8.
8,
Yes,
that's pretty good.
finally, it's twice as good.
That's very satisfying.
And this is definitely a catapult, right?
Well, actually,
It's just using the power of the wind rather than the power of the
Power of the
inclined
pump.
plane or whatever.
I really wasn't sure what the best catapult would be to show off my woodworking tools, but I've got it. I wanted one of my catapults to have a wipe mode, so I'm making a box with a secret catapult in the lid. When you open the box, you won't see anything, but then the secret arm will come down and launch a ball at you.
I have all these woodworking tools because they are surprisingly useful for making functional stuff. Aside from that, I do
Why does
zero
he say
woodworking.
surprisingly?
This tool right here is a planer. It's a DeWalt 735, I think.
Inside of it, there's a spinning set of blades that can remove a
Rax, you
thin
use
layer from a
combustion
piece
for
of
your
wood.
BB
You put
gun?
a plank of wood in one side, and it comes out the other side slightly thinner, flat, and with a good surface finish. My main use of this is when I need accurate flat wood for some kind of fixture, or when I need to make a big flat piece of wood out of small, glued together pieces. I did this a ton for my Crocs project.
This is my compound miter saw. This thing is so useful. I think this is the first power tool I got for this shop. You can cut 2x4s, you can cut smaller pieces of plywood, you can cut
Interesting.
aluminum. I use this on almost every project. This machine is a joiner, and I am absolutely terrified of it. This thing will take you from 5 fingers to 0.
The diagram. The diagram is so cursed.
In the blink of an eye. So it has a set of spinning blades just like the planer, and it removes a thin layer of wood just like the planer. But the difference is that this is designed to make your wood square. So this wood is not square on the side.
This is an extreme example, but you run it through the joiner a few times and it's square. I'm using a router table to
Not
make the
the
rabbit
fingies
joints for
indeed.
the box. There's
It
not
just eats the fingies up. Just eats the fingies up. Like your mom.
Not a whole lot to these. They just hold a router in a very dangerous mangle your hand upside down position. You can also get special bits for deburring and chamfering aluminum and steel. Woodworking machines make a ludicrous amount of dust, so I have a central dust collection system that sucks all the dust out of all the woodworking machines. This is a Grizzly 860 dust collector. It's centrifugal, which is super sweet. And inside the dust collector, it looks like this. At the center, there's essentially a shop vac pulling air in from all directions. And this end is open, it's where it sucks the dusty air in. And because the air has mass, as it comes in, it doesn't go straight into the hole, it actually spirals around and then goes into the vacuum. The sawdust in the air weighs a lot more. When it comes flying in, it can't actually make this sharp of a turn. So it hits the wall, slows down, and drops into the collection bin. The air continues on without the dust in it and gets sucked up into the vacuum. The dust that makes it through goes into this air filter, but it is an absolutely tiny amount of dust, which is really good because it would otherwise clog this filter, which is a huge hassle to deal with. If you're looking at getting a dust collector, I really recommend some kind of centrifugal one. Assembling the box is just straightforward woodworker stuff that I'm not very good at. I'm using a magnet to hold the ball on the catapult upside down. When someone opens this, they don't see the arm until it's too late. I haven't tried to pull any fast ones on my wife in quite a while, so I think I should be good. Check this out.
What's in the box?
It's my woodworking catapult.
So smooth.
Yeah, it turned out pretty nice. Oh!
She read him like a book. Read him like a book, played him like a fiddle. She knew what was going on.
Yeah, it turned out pretty nice. Oh!
She pretends to be surprised, but she knew what she was doing.
Ow! Why would you point it at me?
I've learned.
This gets the 10.
Best for last, I knew it.
Let's see if we can hit something besides my neck. That's not surprising. I tried to make this one only a nuisance, not deadly.
I wonder how many hours it took to make it.
Whenever we had people visit. Ignoring performance, which is your favorite?
Tube.
Tube.
Very satisfying to get in the foam there.
I mean,
I still thought it was hilarious, him pulling out
It's
the
like
little
choosing a favorite child.
I knew you were gonna say that.
I didn't say they're my children, I'm just saying it's like children. I think my favorite's the 3D printed one just because the design is unusual, all the stacked springs. It's like pocketable catapult. I actually really like the sheet metal one for the same reason, but I wouldn't say it's a good design, but it's interesting.
It's not good, but it's unique.
Yeah. I think I may have gotten a little bit carried away with all these catapults, at least a little bit. It was a lot of fun though, and I hope that you enjoyed it. I try really hard to give you a bit more than you bargained for with all these videos, and if you do enjoy them, please consider subscribing. It helps me out, and it'll keep you in the loop when there's some new stuff made here. And like I said before, I designed so many things that I had to gloss over almost all the details. I'm planning to post more videos going into the details of these on my second channel, so check that out if you're interested. So if you think about what's actually happening here, I'm a guy in his basement building catapults for your enjoyment. It is a very strange time to be alive. And the reason I'm able to put so much time into projects like this that are kind of pointless but hopefully entertaining and educational is mostly thanks to video sponsors. So if you want to help ensure that more videos like this get made, taking a minute to check out the sponsor is very helpful. And the sponsor for this video is Micro Center. I'm a huge Micro Center fanboy. The fact that they want to sponsor my videos is still amazing and makes me really happy. It all comes down to the fact that I'm a nerd, I do nerd things, and I need electronics, computers, 3D printers, and I need them now. Micro Center has all that, and their prices are really good. I built my entire computer from parts from Micro Center, and it was cheaper than buying the parts online. It's also the only physical store that I know of that I can go buy electronics kits. If you do anything even tangentially related to nerd stuff, you should go visit a Micro Center. There's 25 of them across the US. Take some time to walk around. You're gonna find stuff that you can't find anywhere else. And if you do go to one, they're doing something I think is a little crazy. They're gonna give you a free pair of Bluetooth headphones, like totally free. So if you're interested in headphones, all you have to do is click on the link in the description, put in your email, and they'll give you a coupon that you can take to the store and they'll give you a free pair of headphones. It's a little crazy they'll give you headphones just for visiting, but I guess they know the store is great and that you're gonna like it. So go check out Micro Center, it is great. And
This is a pretty
if
old
you're interested,
video.
get some free headphones.
I wouldn't expect that you'd still be giving away headphones, but... You said DIY perks. Is this cool stuff? This does seem like fancy.
Coming up in this video, we'll be working with sliding rails, pneumatics, and...
Is this a computer that's just built into the desk?
springs, as well as soldering up a giant heat spreader for an experimental cooling system, all on top of dismantling an OLED monitor. And the goal? Building what appears to be a normal wooden desk. However, you're watching DIY Perks, so this desk is far from ordinary. It is in fact the end game invisible PC. Let's go.
I did not. But now, having seen that, there's just the one thought in my head of like, you're there, you're playing video games, little bit of like a little tiny earthquake, or your desk wobbles a little because you like hit it or you kick your knee on it or something like that, and then the whole thing slams down on your hands.
Now, some parts of this build are going to be super complicated, but thankfully, one thing that I won't have to design myself are the legs, as this video is being sponsored by FlexiSpot, advertising their E7 Pro standing desk system, which I'm going to be integrating completely into the build.
I'm sure it does have some safety features, because safety features are important.
Adjustable height desks that can change.
Mr. E, a lot of his machines are hobby level. You're talking about Stuffmadehere, right? I'm not sure how old that comment is, but I mean, I don't know. They seem pretty impressive to me.
Change the way you interact with your computer. Now, thanks to the way the legs have been designed, they can actually be mounted onto custom desktops.
I mean, also the other thing is I don't have space to put all those tools. I'm pretty sure there's like creator workshops around here. Creator space type workshops where they would have the tools and I could probably go and use them though.
Which I'm going to take full advantage of by making a massive custom desktop so we have enough room for the various mechanisms that'll make the invisibility concept work. And just like my last desk PC build, I'm going to be using for its main structure 2 sheets of 3mm thick aluminium. Now, as you can see, it is somewhat bendy, but that's easy to fix with some extruded aluminium lengths. By screwing the aluminium sheets directly to these, they become a lamination, which brings some significant advantages while remaining hollow. You see, these sheets were super floppy, but just look how rigid they are now that they're bolted together. And
I didn't realize it was this big. This thing is huge.
So with all that done, we're now
like a dining room
to start working on the potentially
galvanized steel beams. Easy.
Quite complex mechanism to make the hidden monitor system. Despite
just
how
fit everything
complicated
into
things
a
are going to get, it
box.
starts out being quite easy, as cutting a hole for the monitor to fold down into only takes a few minutes using a jigsaw, as aluminium is quite a soft metal. Choosing a hinge for this is where things...
Also, this fucker, I mean, I should have known from hearing his accent, but fucking aluminium? Aluminium? Really?
Start getting a bit more involved though. You see, simple hinges like butt hinges would leave a visible edge, going against the concept of the build.
It's aluminum, bench. It's aluminum. Aluminum, Deo.
But what about concealed cabinet hinges? These are definitely more like it, but unfortunately they don't rotate around a stationary point, as this point literally moves as they open, making them difficult to figure out how to design around for a non-standard use case like this. Ultimately, after a lot of experimentation, I've settled on some rather unusual invisible hinges, which thankfully have a purely rotational hinge movement, making them far easier to design around. And with them mounted in place, the hatch can open and close without the hinges being visible in the
I mean, when I saw the finished product, I probably should have known there was metal. It looked so good with the wood finish that I completely blanked on the idea that, of course, you probably want this to be metal, right?
Closed position. Perfect. With this now sorted, the complexity is about to skyrocket.
Organic? It's wait. Excuse me? Excuse me? Okay, here it is. In North American English, it does not have the I. I spelled it correctly. It's aluminum. So it wasn't a spelling issue. Just to be clear, this is not a spelling issue. But why do you have the I? Like why does the I make sense? I don't know. Aluminum sounds way better. Wait, was it this one? No. This one? Yeah.
Though, as we need to use this rotational movement to affect the height of a platform in front of the hatch, basically turning rotational movement into linear movement. Before we can get going with this though, we need to make the platform itself, which can just be cut from the lower aluminium sheet, making it look a bit nicer.
It bothers
with
me
some
every time he
vinyl
says it.
As this platform needs to have various components mounted to it, I'm going to utilize some V-slot profiling to give them adjustability, as they can be used with captive T-nuts anywhere along their length. This allows pretty much anything to be added or taken away or adjusted as required, which is going to be very important for the mechanisms we're about to build.
Because aluminum's correct, compiler.
The platform to purely
Where are you from, compiler? Where are you from? Are you from one of the wrong places? Are you... Okay, so why is it not Canada? Huh?
Down movement, and it's
I
going
think I have heard people call it Canada.
based is going to be limiting the platform to purely up and down movement, and is going to be based upon some linear sliding rails. These work thanks to having
Maple
tiny
Land?
bearings inside a guide carriage for smooth
Syrupy.
operation, and thanks to the V-slot profiles, they're very easy to mount in place, with one in each corner. Once they're mounted to their accompanying rails, they allow the platform to slide up and down as required.
Okay, wait, this actually bothers me now that I see it, because...
rails to mount in place.
Sorry, I got distracted with our aluminum conversation.
With one in each corner. Once they're mounted to their...
I don't like these linear rails in like 4 spots, because it ends up with what's called binding. Unless I'm sure he has a functional table at the end, so it clearly works out for him. But I am very much opposed to lots of linear rails in parallel, because if you have like 2 linear rails, right? And theoretically you should be able to mount something to them and it should just slide up and down, right? But if you're even a little bit off, right? One of them's a little bit slanted, or they're... In this case, it's 4 of them, right? 4 of them have to be very, very correctly straight. And if they're not, then what ends up happening is your thing binds and it won't go that far. Because, like, for it to be up here, suddenly the rails are, like, close together. Whereas further down, they'd be far apart. So, like, it just physically doesn't work out. Why do you have I in America? Merca. We have I in America because it's all about me. It's all about me. That's why I is in the center, because I am in the center of everything here. Classic American mentality. But anyway, that was my quick tangent in, like, there are obviously ways to work around this binding problem, right? And normally if you have multiple of these, like, linear slide rail type things, what you do is you build in like a spring-loaded component that allows it to move, right? It gives it some little bit of play so that even if it's not perfectly lined up, it just, like, adjusts, right? It just pivots or slides. Oh, skill issue. We're watching some video from some channel I haven't seen about building a fancy invisible desk. But earlier we were watching people build robots that solved puzzles, which was pretty cool.
Place with one in each corner. Once they're mounted to their accompanying rails, they allow
We are in a civil war about spelling.
the platform to slide up and down as required. But how are we going to control its height purely from the rotational movement of the monitor hatch? Well,
I mean, I do want to say, even just watching it, you can see that different parts of it come up, like, it wobbles a little as it goes up. So if you didn't have, I mean, he must have something built in to allow for, like, a little bit of play. But that already is a sign that, like, it's not super rigid and it's not super lined up, necessarily. Because otherwise it would be very smooth. Everything would rise up, you know, perfectly at the same time.
Slide up and down as required. But how are we going to control its height purely from the rotational movement of the monitor hatch? Well, the key relies on the addition of another set of linear rails to the top of the platform, linked together with some
Arcanic? It's because we obviously have the superior system. When we do thermal analysis, obviously the superior set of units is Rankine. I don't think I've ever met anyone who's ever actually used Rankine for anything. But one day I'm gonna walk outside and someone's gonna ask me the temperature and I'm gonna respond in Rankine and they're gonna be like, what the fuck is wrong with you? It's not like 600 degrees outside.
aluminum strips. That these can slide back and forth is vital, as the intention is to use.
Okay, also, since we're on this topic of, like, weird word things, now I have to point out, do you guys know, Mr. E probably knows, in imperial units, right, we have, like, inches, right, and when we need to machine things with, like, lots of precision, you know, we need a much smaller measurement. What we use is we can use, like, a division of this by 1,000. And we call this two separate things. Option 1, actually option A, we call it thou, as in thousandth of an inch. Option, I was going to say B, but just because it doesn't make sense and it's inconsistent, we go from option A to option 2, and we call it mil. So it's thou and mil, and it's not, this is thousandth of an inch, this is not millionth of an inch, this is still a thousandth of an inch. We call it mil, like millimeter is a thousandth of a meter. But this bothers me so much, right, that thou and mil mean the same. It bothers me so much. You've never heard someone say mil. Interesting mystery. But if you've ever, one day maybe you'll hear someone say mil. But people do say mil. I remember because I was doing an analysis of some thermal pads, and I was like, oh, this replacement thermal pad, we went from 5 thou to 10 thou. And I was telling my like chief engineer, and he's like, oh, I mean, the difference is only 5 mil. And it flabbergasted me because I always like to use thou. I prefer to use thou, but people actually, like, real people use mil. You got mentally crowd-striked by that skill issue, by this? Yeah, it should bother you. It should bother you because it's so ridiculous. So ridiculous. But anyway, back on topic from my tangent of silly word things.
Use them with some heavy-duty L brackets.
Mystery, I'm a fucking engineer. Don't talk badly about us because we're the best. We're the best.
These are custom made
Oh,
to be of
right.
the required dimensions and have bearings installed to provide an easily rotatable point where they're attached to the additional sliders. Now, while everything is upside down in these shots, you should still be able to understand what's going on here. With the other side of the brackets screwed to the monitor hatch's rotational movement causes the other end of the L brackets to be forced further away. And because they're linked to the platform,
Sorry, we got so tangented. I missed how this mechanism works.
Rotational movement of the monitor hatch. Well, the key relies on the addition of another set of linear rails to the top of the platform, linked together with some aluminium strips. That these can slide linked together with some aluminium strips. That these can slide back and forth is vital, as the intention is to use them with some heavy-duty L brackets. These are custom made to be of the required dimensions and have bearings installed to provide an easily rotatable point where they're attached to the additional sliders. Now, while everything is upside down in these shots, you should still be able to understand what's going on here. With the other side of the brackets screwed to the monitor hatch's rotational movement causes the other end of the L brackets to be forced further away. And because they're linked to the platform through the sliding sections, the platform is completely free to follow along. Cool. As you can see though, it only affects the rear side of the platform. But as the sliding section runs all the way to the front, we can actually use some extra identically proportioned brackets to exploit geometry and turn it into a parallelogram, forcing it to remain flat no matter what. With it flipped the right way up, it's now the moment of truth. Will it work? Hey, look at that!
That's pretty good.
Much to my joy, this works a treat, with the opening of the hatch resulting in the platform rising up to become flush with the rest of the deck.
This still looks
the most important milestone of this build. As you can see though, it does have a tendency to slam closed.
Ooh,
but this is easily fixed with some pneumatic struts.
Imagine your computer monitor slamming closed like that.
Are happy to close with very little opposition. So, by attaching them to the V-slot profiles, they'll restrict the movement of the sliding section and force the hatch to close softly. I'm also integrating some tension springs to help them along, as they'll counter the effect of gravity on the platform and the hatch, and bias them towards their opened positions. This balances the system beautifully, providing not only a nice soft close action, but making it much lighter to operate as well. To finish things off, the use of some magnets allows it to confidently lock into its open position when it gets there, which makes the platform feel surprisingly solid. There's plenty of space for a keyboard and mouse here, and the mechanism moves them out of the way completely to make room for the screen. Speaking of which, seeing as it's such an important feature, it makes sense to go with one that's rather special. You see, computer monitors have gone through some major advances in the past few years, to the point where we can forget about old-style LCD panels like this entirely and use a vastly superior OLED one instead. Now, as you can see, this is an ultra-wide, which is a fantastic format for both gaming and productivity, but what makes it particularly special is that it can be made flat. An essential feature for the desk, as it makes the monitor's profile super thin.
That really, there was just a part of me, right? My heart dropped as I felt like he was bending the screen. I was like, oh no, rest in peace, monitor.
Its electronics pose a challenge though, as they are on the back, so need to be detached to be hidden elsewhere. I'll be honest, dismantling such an expensive monitor is a bit scary, but there's not too much that can go wrong so long as I'm super careful. This one is more complicated than most due to its adjustable curvature arm, but once everything is finally stripped down, I'm left with the raw OLED panel. It's incredibly thin and also thankfully incredibly light, but it does have some proud mounting cylinders that will prevent me from attaching it directly to the front of the monitor hatch, as they are simply in the way. My only real option is to drill holes in the monitor hatch for them to hopefully disappear into. As this is also a bit floppy though, I've made two identical copies to make it 2 layers thick, with some vinyl wrap around its perimeter to finish off its visible edge. Once it's reattached, a front plate can also be installed directly onto it. This again helps with rigidity, but it also provides a lip for the OLED panel to rest upon. Now, so much of the build actually relies on this installation going smoothly, and if it
You
goes
must have
wrong,
taken really
it's
precise
going to be
measurements.
extremely costly.
I
because
hope.
This panel and the screen was like 2K, so yeah, there's a lot resting on this actually working well. So I'm just going to lift it up, and it's going to stand
Part
on
of
that
me
lip,
felt like he was going to
and
drop it.
these holes at the back should allow the little noggins to go through. And as each of these noggins has an internal thread, I can use them in conjunction with some washers to pull them tightly in place. There's just enough room on the bottom here.
Also, cursed intrusive thought, like, seeing him tighten this, I definitely had the thought of like, damn, you could definitely, you know, just barely accidentally over torque this, pull a little bit harder on the screen than you should, and probably fuck up your monitor in that one single like half turn of the screw.
In place. There's just enough room on the bottom here to connect one of the two control boards as well, with the other tucked inside the desk behind the hinges. With the screen now installed, the concept really is
pretty
starting
nice.
to come together, and it's looking pretty awesome. But as this is just so unique, I think it deserves high-power PC components for inside it. The ones I have for this are some of the highest end parts available right now. An Intel 13900K on an RTX motherboard,
I want
and
a new
Zotac
computer.
4090 graphics card. To get the most out of them, I am of course using water blocks so that the heat that they generate can be pulled away from them as quickly as possible. And of course the other benefit of using water cooling is that it keeps their profile quite low, so that they can fit within the desk, using some PCB pillars to make them nice and secure. As there's not quite enough room for a normal power supply though, I'm using a set of gallium nitride alternatives. These can deliver 500 watts each, one of which is dedicated for the motherboard and CPU, and the other for the graphics card. As for storage, I'm adding a flash store NAS that I'm populating with 12 4TB flash drives for a rather gargantuan 48
That's
terabytes
so much.
of space, accessed
That's so
directly
much.
through a 10 gigabit M.2 network card.
I mean, I guess it makes sense to just like load it with huge storage space because you don't want to have to ever take this thing apart, right? Like, you want to build this once and have everything you need forever in it because taking this apart sounds awful.
We are, after all, going for the end game here. With everything wired up and the water blocks connected together in series, we need to think
48
seriously
terabytes,
about
though.
how we're going to deal with.
Wait, ads, rest in peace, ad sufferers, ad not enjoyers. Just gonna chill for a second. Oh man. Seems like people are enjoying the semi content stealing YouTube video reviews though. We're having a good time. Your ad is done already? Why do you only get 30-second ads when my thing says it's 3 minutes? That's really odd to me. Because I feel like if you're not gonna get ads, you're not gonna get ads. I think it's like just sort of throws me off that you get like 30-second ads instead of 3-minute ads. Yeah, skill issue. I also don't know why you don't get ads. Are there any copyright issues with watching YouTube videos? I don't know. I don't think so. As long as they're not using like copyrighted music, because I don't think people are like copywriting their videos, right? And I've seen plenty of other streamers do like, you know, do react video. People react to like Daily Dose of Internet all the time. So, I don't know. If I get an email from Twitch telling me, you know, I messed up, then maybe we'll figure something out. But it does, I think lots of people watch YouTube videos and review them on Twitch, right? That's like a pretty big content area, especially for VTubers, right? So, I don't know. You wanna like
4 terabyte flash for storage. I'm adding a flash store now that I'm populating with
Look at this thing.
12 4 terabyte flash drives for a rather
Like,
again.
first of all, I don't. Where are the heat sinks for all these
48 terabytes
drives?
of space accessed directly through
But that thing is like a chonker storage unit. YouTube can be okay. YouTube can be YouTube is fine because I'm not monetized on YouTube because I don't think I have enough subscribers or view hours. Not that I'm like really making money off Twitch besides donations. Gojo ever just pops in and like donates a bunch of money? Gojo the Oiler?
M.2 network card. We are, after all, going for the end
ads
game
done.
here. With everything wired up and the water blocks connected together in series, we need to think seriously about how we're going to deal with all of the heat that these components generate, as they total over 800 watts. And standard PC radiators aren't really an option because they're just so thick. While smaller radiators are definitely available, I have an idea that I really want to try, which is to use these old server heat sinks. As you can see, they've got a really fine fin structure, which makes them extremely effective at transferring heat into the surrounding air. And they're the perfect size to match these laptop fans. If you recognise these are actually from my previous project where we made a portable PS5, and if you remember from that video, these fans are bi-directional, which means
I feel like this isn't enough.
Cool 2 heat sinks at once. And in this configuration, they can actually get rid of 40 watts of heat silently. Now, obviously, that's a long way shy of the required 800 we need to get rid of here.
Okay.
And that's why
So
I bought 40 of them.
Okay,
This
there's
is
a lot.
possible
Okay,
only
that makes
because
sense.
they are just so cheap, as they are, after all, from decommissioned servers, and are available online for pretty much nothing. In order to combine them together into one giant heatsink though, I've bought some brass box sections to make a massive heat spreader for them to attach to. As you can see, these are completely hollow, which is important as the idea is to have the water that cools the components flow through them to transfer
The math
all
problems
heat
where the
into
person's like
brass.
buying like 40
To do
watermelons.
this effectively,
No,
they
I'm just
each
buying
need some
30 heat
holes
sinks.
drilled through them so that the water can flow from one to the other. Being brass, they can of course be soldered together really easily, making each join watertight. In order to provide some water entry points, I'm simply using some barbed elbow joints, again using plenty of solder to ensure that there won't be any leaks. The intention with this is for water to enter one port and go up and down its entire length a few times before exiting through the other port. As the surface area of this new brass construction is so large, it basically becomes a massive heat spreader, which allows all of the heat sinks to work in tandem to
I
remove
don't know if I
all
think
of the
that's the
heat
right
from
configuration
water.
for this. But
Now it does end up being super heavy, but thankfully I don't
I
have
also
to
don't
worry
know what
about
the
this, as
correct
the
one would be.
FlexiSpot desk
But
is
something
capable
about
of
it
load up to
rubs me the wrong way.
160 kilograms. So me and my dad should weigh about 160 kilograms together, and the desk can handle it, no problem. It goes so high, you could actually paint a ceiling really easily.
It's taking that weight.
And this is a lot of weight. This is 2 people.
Yeah.
Like, it's a lot. So I don't think it's going to have any problems holding those heat sinks. Having so many heat sinks though does mean we need quite a few fans to keep them all cool, with the idea being that they should each work at a slow speed to operate quietly. In order to take advantage of their bidirectional air output, I've 3D printed some air ducts that can take the rear output and push it back towards the top heatsink, so they both get cooled at the same time.
Wait.
Push it back
So-
towards the top heatsink.
It sucks it in through one and out the other. I also don't know if I think this is the correct way. But whatever.
So they both get cooled at the same time. Now, wiring up so many fans has the potential to be quite a tedious job.
I don't think that's
Thus, my favourite method to speed things up is to use
the
strips
best.
of copper tape to make some voltage rails, with the third strip carrying a fan speed.
You're worried about the weight distribution? I mean, I'm sure the weight distribution is just like... I'm sure it's not that big a problem, right? Because if you think of a desk, even if you put your computer right, and all that stuff, and you put it on the side of the desk closer to you, probably wouldn't like tumble.
Control signal, known as a
I don't know.
PWM
Maybe,
signal.
Probably not. I don't think.
After hooking
I
up
don't
the
think this is
custom
that heavy.
brass heat spreader to the main water cooling loop, the whole thing is ready to
And
be
I guess
filled
this is
with
probably on the
coolant.
back side,
As there
too.
hasn't really been room for a proper reservoir inside
would
the
probably be
PC,
closer to
though,
the legs.
I'm using an external pump to force the water into the system, as it allows me to get rid of any air pockets by temporarily looping the coolant through the external plastic container. Before we can test it out though, it does need closing up with the bottom panel. Since you last saw this, it's had a variety
Oh no,
of
it actually is.
holes and
It is on the
cutouts
close
made in
side.
it, most of which are for
What I'm thinking is you're like sitting at your desk running your computer and you're just feeling it blast the hot air at you.
purposes, and to allow for easily removable
just
covers
blasting
for
hot air
access
into your
to the
stomach.
internal components. So,
Or
although this is
maybe
on the
it's
bottom
not.
and won't
Maybe
really
we're
be
looking at
seen,
the back.
having it finished in this
I don't know.
vinyl wrap makes it look really rather smart. And honestly, I'm pretty happy with how it's turned out. But before we flip it over and start working on the top section, which is of course still raw aluminium, I'm getting fed up of it just being perched on top of my workbench. So I think it's high time that it has its own legs. And this is where we're going to be installing and integrating FlexiSpot's standing desk system. Now this is the E7 Pro, and I've made some slots for the legs to be fitted into like so. Now, if you weren't integrating these into such a custom project, they'd normally be installed onto their robust
I
steel
think my mom
frame,
has one of these.
which is how FlexiSpot have managed to maximize rigidity on all of their desks. This steel frame also houses the control box, with a smart magnetic cover keeping it all neat. For me though, I've housed this control box inside the spare chamber opposite the PC components, where all the cables for it can be plugged in. So with the feet added, the next job is to get this upright, and I think it's a bit heavy for me to do on my own, so I'm going to employ some help.
I'm surprised this is even like a two-person lift. I think this would
That's good. Look how solid that is.
probably be like a 3 or 4
Hey,
person.
look at that.
Is what I would probably want to do.
How
but
cool is this?
maybe not.
Now let's try out the FlexiSpot legs. Oh yeah. Oh, that's smooth.
It looks pretty nice.
Check that out. So I've just adjusted it up, and it should be about the right height to use
Does look
as a
quite
sit-down
nice.
desk, which it is. But what if I want to...
Also, but is it just me? Does it seem like it's bowing in the middle? It's too long, so it's like sagging in the middle? Or is that just me? I feel like it's sagging in the middle.
stand and do some work standing up, which I personally actually prefer a lot. Well, with the push of a button, I can actually raise this up, and it becomes a standing desk.
Maybe not.
Look at that. And if you're particularly tall, it can go really high. It just keeps going. And
Maybe.
going, and going.
Maybe it is straight.
And we're done. So it comes to a nice stop. Now, as you can see, the raw aluminium
I'm just thinking,
doesn't really
like,
suit being a
especially
desk
if you, like,
surface.
rest
we
your
need a way
arms
of
on it,
covering it with a
is it
much
gonna
more
slowly
suitable
over
material.
time gonna
I've
creep
encountered
down?
this problem before, of course, as the original invisible PC was also constructed out of aluminium, which I gave a wood appearance by gluing thin wood veneer on top to disguise it. This hasn't really stood up to the test of time though, as some parts of it have started to peel away.
Oh no.
So this time round, I've ordered some massive oak planks. Don't worry, I'm not about to stick these on top and call it a day. I took them to a joiner to have them divided up into many smaller and thinner lengths. Compared to veneer, these are still much thicker though, and are actually structurally sound, and will make a much more robust covering for the desk. I'm using some CT1 glue here to stick them down to the aluminium, being extremely careful to make sure that they fit nicely around the monitor hatch and
You must
the
have
keyboard
really
platform.
good craftsmanship skills.
Another advantage of
to, like,
using
cut all these
thicker
things
wood
properly.
compared to veneer is that it's possible to route out some patches of it underneath to make room for any elements on the desk that are proud of the main aluminium surface, like the back of the monitor's wiring and some of its threaded noggins. If you're wondering what the white patches are, that's actually wood filler, which goes into any gaps or knots to make them smooth once it's sanded down. So with all of the wood added, it really hides the aluminium well. But what about the front and sides? Due to all of the mechanisms that have been jammed inside the desk, it's not actually super thin. But to make it appear much thinner and more elegant, we can employ another illusion: tapered
he's
edges.
cheating.
As you can see, these have an angle to their underside, which means that once they're glued to the outer perimeter, they give the desk a much thinner appearance, with only the thinner
It does
edge
look
being
really nice,
visible. Very cool. The mitre joints in particular are a really nice touch, and I've got my dad
really
to thank
big
for
desk.
this, as he made these extra sections, and that's why they're so precise, as he's a much better woodworker than I am. After giving it a thorough sanding down, it looks absolutely fantastic, and the final job is to give it several thin coats of oil to bring out the richness of the wood. When putting oil on oak, it can end up with a pretty bold honey-coloured finish, which I'm personally not a fan of. So to avoid this, I'm using a combination of two types of oil to give it a lighter appearance. The difference with this technique makes it look almost like a different type of wood, and is definitely more to my tastes. Being oiled gives the surface a cohesive finish, with the hatch barely being visible now, except the back edge of course. As the hinge point is below the surface of the wood, a groove has had to be made to prevent the wood from intersecting and jamming as it opens. To make it completely invisible, I've made a little spring-loaded insert that can fill the gap.
Oh, he did such a good job.
With the idea being for it to move out of the way as the hatch opens and pull itself back in when closed, and it's surprisingly effective.
It's
And
so
with that,
it's like
the
seamless.
Endgame Invisible PC is complete. Just looking at it, you wouldn't assume that there's an entire piece.
It does like this. It looks too long. It looks way too long. I mean the desk, of course. As a desk, it's too long.
PC setup here.
Nothing
the
weird.
Thought that there's a monitor, keyboard, mouse, and a fully water-cooled
Maybe
selection
it
of
could fit like 2 people.
high-end components right here in front of you is kind of wild. Even if you did know it was here though, how on earth is it supposed to be opened? Well, the secret lies with what appears to be a silver paperweight. It might appear rather ordinary, but it's actually a super strong magnet. Of course, it's not attracted to the aluminium at all, so even when resting on the desk, it doesn't give any clues away. But earlier, I embedded a steel sheet into the top edge of the monitor hatch underneath one of the bits of wood. This gives the paperweight a specific area to be strongly attracted to, allowing it to become a sort of key that can be used to open the system up.
Interesting.
Thanks to the internal sliding rail mechanism, this opening action brings the keyboard platform up to be flush with the rest of the desk's surface. And because it moves so thoroughly out of the way when closed, there's space for pretty much anything you can think of. Here I've not only got my full-sized mechanical keyboard and mouse, but I've built a little speaker system and dock as well. Even headphones and an audio interface can be fitted here, all to be made invisible
And
with
losing
one
the magnet?
simple
Yeah.
movement. That this works so well
Must be
is
super strong
hugely
with it, too.
satisfying, especially having spent so many weeks making sure that this mechanism works properly. And that it's on FlexiSpot's adjustable height desk system gives it that final level of polish. Now, one aspect of the build that hasn't been tested yet is its cooling system, which is rather unusual, so let's put it through its paces and make sure that it can actually keep the hardware.
Also, it's the hot air, right, from the cooling system goes out. It appears to be of the back of the desk. And if you butt this desk against the wall, are you gonna overheat? Because everyone's gonna, like, that's what you do with the desk, right? You basically butt it up against the wall. Probably not good for the cooling, but
in check. For this, I'm running 2 bits of software at the same time, Prime 95 and Furmark. These stress the CPU and graphics card respectively to push them to their limits for maximum power draw, the heat from which has to be gotten rid of by the cooling system. As the components I've used are pretty much the highest end parts you can get right now, it's a lot of heat to contend with, and ideally we're looking for them to flatline in temperature. But disaster. They don't. the temperatures of the components keep going up and up,
Yeah.
ultimately reaching their maximum and throttling to keep themselves from overheating. And what's worse is that this is with the fans at full pelt, making a lot of noise. Now, this is supposed to be the end game invisible PC,
Thermal issues.
so that its cooling system isn't working anywhere near where it should is pretty annoying. So what on earth is going on here, and what can we do about it? Well, after some experimentation, it appears that the issue lies with the airflow path of the fans being too restricted by things like the air ducts and, ironically, the fine fin structure of the heat sinks, resulting in them barely moving any air at all. It's actually so bad that I think...
Oh yeah, I should have thought about this earlier, but I remember reading a Reddit thread on someone specifically asking about this on like computer heat sinks, right? Because your air cooling on those heat sinks, they were talking about like, oh, we have such high precision, shouldn't we have more fins, right? We can make heat sinks with more fins. And then people were talking about like how analytically it's not necessarily better to have more fins, even though that's more surface area, because you still need enough space between the fins that you can get actually cool air between them, right? Because if they're too close, then what happens is the air in between them heats up too quickly, and you don't end up with any really like the profile of the heat from one fin starts getting absorbed by the other fin.
Best course of action is to completely remove this version of the cooling setup and come at it from a different angle. This time swapping out the small bi-directional fans for some normal 140mm PC fans. You know, there's a reason why they use them in PCs, and sometimes, just sometimes, it's worth going with the crowd and not experimenting too much. They do of course protrude beyond the bottom of the desk now, but I don't think that this will be too much of an issue, as they are at the back after all and
Those
will
things are
never really be
large.
seen. These obviously can't be made to work with the old heat sinks, so I'm swapping them out as well in favour of some that have a significantly wider fin
There we
spacing
go.
as well as a taller height, and this should help keep airflow restrictions to a minimum. These heat sinks are also from decommissioned servers and are even cheaper than the first set, despite being much larger and arguably nicer looking thanks to their nickel-plated finish. From here it's pretty much the same as before. The heat sinks can be placed side by side right along the back of the desk, with the custom brass heat spreader being sandwiched in between them. It looks kind of wild, and I've never seen so much heatsink surface before.
That looks heavy.
This might seem a bit over the top, but the thing is, these heat sinks have cost less than a single computer radiator. So in terms of value, they're actually excellent, but will they fix
So
the
thick
cooling
indeed.
issues? There's only one way to find out. Well, yeah.
Very
yeah,
thick,
they do.
very chunky.
Perhaps a little unsurprisingly, this quantity of heat sinks absolutely obliterates any heat
Oh
in
god,
this
they're
system,
spinning so fast
and it's
too.
able to keep all of the components cool without even breaking a sweat. I mean, the fans are turning at
hope
about 400 RPM, and yet they're keeping 800 watts of PC
Yes, they're
cool
not spinning that fast, but-
silently. And I really do mean silently. Here's a little example. So you're presently listening to the audio output from this studio-grade microphone. So if the PC is making any noise, you should be able to hear it. I can barely hear anything. That's absolutely fantastic results. Remember, this is running Thermark and Prime 95. I'm happy with that. Now, although this heatsink setup is far larger than the old one, it's not at all visible unless you're literally on the floor. So there really is no compromise for getting pretty much the ultimate in cooling performance.
So this was a
It
really
can
cool
handle
project.
anything that's thrown at it while remaining inaudible. Speaking of compromises, there are certainly none here. We've got ultra-high-end components driving an ultra-wide OLED monitor with a full-sized mechanical keyboard and mouse. And would you know any of it was here at all? Mechanical
Wait.
keyboard and mouse. And would you know
Guys,
any of
he didn't do
was
anything to
there at
unlock
all?
it. It just free
mechanical
closes.
keyboard and mouse.
I am totally imagining
And would you know,
earthquake and it falls down. I mean, it seemed like it slow closed earlier, but
I'll let
earthquake and it just falls on your hands.
you be the judge. Of course, we can't forget the ergonomic benefits of it being on a FlexiSpot adjustable height desk system, which allows it to just simply become a standing desk with the press of a button, which is really good for your health. Now, if you want to get a standing desk system for yourself, actually, FlexiSpot right now have their brand day deals on, and using the code DIY Perks, you can actually get $50 off their E7 Pro or E7 Plus standing desks. There's plenty of different desktops to choose from as well, so you can select something that matches your decor, and it really is one of the best value upgrades you can have to your setup that will have real-world implications for your well-being.
Out of 10?
So, highly recommended. I love
what are we rating it based off of?
Through the link down below.
You know, like
But
finished
other than
product,
that, I do
or
hope
like
you've enjoyed seeing this end game invisible
how
PC.
interesting it is,
It's been
or
a wild one. It's taken
you know,
so much effort.
on
but
an
I think
engineering
it's been
level,
worth it,
what I
because
like or
this thing,
dislike, like
I
what?
think,
How are we
has
rating
the
it?
highest end finish of anything I've
Mechanic.
built.
If you want me to rate it
Now,
out, of 10.
a quick shout out to.
I'll say finished product. This is probably a 10. It looks very nice. I mean, I don't know if that's just because, you know, seeing a video, we can't like inspect it the same as we could up close.
Homeless for
engineering level.
For me to revisit this topic again, yeah, I wonder what he'll do next.
Engineering level. I think this is. I didn't see all the stuff, all the work that he put into it, right? Because we only saw what was in the video, and I'm sure there's tons more that went into it than we saw. But I don't know if I like all the stuff, the way that it was approached. Especially like the way that the linkages worked for everything moving in the folding screen. I feel like it's maybe not. It doesn't seem like it would be as robust as it might appear. I think altogether this is probably like 7, maybe. With mechanically the movement, I think probably closer to 6 is where I want to put it. Maybe 5.5. But I think, you know, the thermal solutions, probably a little bit higher. That's probably closer to like 8. Just the way he did the heat sinks and the heat spreaders, and the way he was piping the water through. I think seemed pretty good. Even though I don't know if it was analytically the best way to do it. I think it was a really good solution though. So yeah, I think probably altogether like 7, maybe 6.5.
Other than that, I'm Matt. You've been watching DIY Perks, and I hope to see you next time. Goodbye.
I don't think much of it was like revolutionary. And again,
see you next time.
It does bother me. It does bother me that it does not appear to have any mechanism that locks it up.
For now.
Like, if you're going to put in the effort to build this, you better make sure that it has all the bells and whistles that make it functional, right? I do not like the idea that this can close when you don't want it to close.
For now.
So I don't know, but it's definitely cool, right? It's definitely interesting and novel and well executed. 4 magnets at the back when open. When you say 4 magnets at the back, what do you mean 4 magnets at the back? Like holding the
taken so much effort, but
holding the back thing open somehow? I imagine you mean something like right? So like this is your desk, and then this is your like folded up screen that pivoted from down. I imagine you mean some sort of magnet configuration that you know, had some attractive force pulling this way to hold it up, but I'm not entirely sure. The keyboard area moves down, but then what if your hands are here? I mean, it's silly sounding, right? But I think regardless of if it actually breaks anything, I think you should not have a design that can accidentally close. Just at a very practical level, there's no reason. Like, it should be easy enough to have a solution for that. Over-center mechanism. What do you mean over-center mechanism? But, I mean, I would have wanted... Like, he clearly knew his way around linkage systems, right? With his like, L's, right? That were bringing this floor up. I think it would have been... should have been well within the realm of possibility that there be some linkage that literally just locks into place, and then there's some little spring release button that you have to push in to bring it to close it back down. That should definitely be within the realm of possibility. Or if not here, if not like a long linkage, then there should be like some press release lock that can be on the desk surface, right? Like if you're looking at the desk from top view, and this is like your screen, you could have, I'm sure there's some way you could spring load buttons right next to the hinges of the screen. Okay, have a good lunch, Arcanic. I probably won't be streaming for too much longer. It's pretty close to the end of my normal stream time slot, but I had a lot of fun. I had a lot of fun watching these videos with y'all and yapping about silly, stupid engineering stuff, and even not engineering stuff, like how to properly pronounce aluminum. I hope you'll come back for more streams in the future. What time is it? It is midnight. I can't believe I ended up, like, drawing such... The hideous diagrams always return. But yeah, I mean, this is a cool channel. I'll probably be checking it out a little more. I've never seen it before. But these like, at-home projects are pretty interesting. Yeah, thanks for coming, Compiler. I will probably be streaming again Tuesday. Tuesdays are normally teaching streams. I don't know what I want to teach this week yet, but Tuesday, 7 p.m., probably a teaching stream. If not, maybe we'll do something lazy. Maybe we'll still watch, like, some semi-educational stuff like this. But, yeah. And then I'll be back to streaming again after that. Friday and Saturday. But, yeah. Thanks for watching, guys. I had a good time. I hope you guys all have good days or nights. And I'll see you guys. Teach us how to do taxes. Rax, I can't teach you what I don't really know. I go on H&R Block and I fill out the boxes as they tell me, and that's that. I'm probably not saving as much money as I could, but to me, that's not the end of the world. Okay. Anyway, probably ending stream now. It's a little bit, tiny bit earlier than normal, but we're close enough, right? You don't pay? Oh, you don't pay... Wait, Rax, you don't pay at all? Or you don't pay yet? Or you don't... Are you an illegal tax evader? If you are, don't tell me. But anyway, thanks for watching. Have a good night. I'll see you guys next time. And, thanks again. Have a good one.